Okay. So, hello students, can you see me? Am I audible? Okay, so hello everyone. In today's session, we have around 100 problems. Okay, slightly less than 100 problems. So we will discuss them quickly. Okay, so we won't cover it in detail here. So we'll quickly discuss the logic. So these questions I have selected mainly once again from last year's PYQs only. And once again, I have tried to keep the distribution as uniform as possible. So, all right. Hi, Black Mystery. Okay, so we can start. The duration would be, I guess, till 2 a.m. max. Okay, so the first problems are mainly from the April shift problems. Okay, so basically from the first shift and the second shift. So this question is based on, it was an April shift problem. I don't remember which shift exactly. So here we have a rod, okay, a cylindrical rod, and the rod's weight is W itself, the same weight as this mass, okay. So we have to find the stress at this location, which is at L/3 from the base of the rod. Okay, so that is the first question. So paper is tomorrow. Yeah, I mean, if you guys are night owl types, you can stay. Otherwise, yeah, you can go to sleep, and all the best for your exams. Okay. So, okay, if you're tomorrow first shift, then you should probably skip this, right? Otherwise, it may stress you guys out. All right, so yeah, let's begin. So the stress at this L/3 location is what we have to find. So L/3, so if this is the rod, okay, so it's a uniform mass distribution. So from the base, if I'm talking about L/3 length, right, what will be the weight of this part? It will be 1/3 the total weight of the rod, right? So this part will have a weight of W/3, and we also have a W included at the base. So this W/3 plus W is going to be 4W/3. That will be the force at this location, at this cross section. So at this cross section, the net upward force, let's call it F. What this force will do is balance out this W/3 and this W, which will be 4W/3. Okay, so now once we have the force, the stress, we can find it out as force divided by area. So that should be it. Okay, and then you can just find gamma. So the answer will come out to be 6 in this case. Okay. So yeah, so the answer will come out to be 6 in this case. You guys can do the calculations and do it. The simple answer is 4W/3A. Then you can compare it with that. So the next question, this is also an April shift problem. It's a very popular question. So we have a cylindrical roller type of a situation, and the cylinder is rotating about this axis, but we have a mass, a tiny mass attached to the cylinder, okay, and it's staying at rest with respect to the cylinder. So if that is the situation, then we have to find the minimum coefficient of friction mu, right? Of course, there will be friction from the surface that is balancing out the mass. We have mg and the normal force. Now we will work in the frame of the cylinder, right, the rotating frame. So we will apply a centrifugal force as well on this block. So that will be radially outward, and its magnitude will be m omega square times the radius of the cylindrical path. And now it's a force balance question. Okay, all you have to do is balance the forces. Yeah, these are not types, these are the April attempt questions. The first few questions are April attempt questions itself. Okay, so yeah. So yeah, now it's just a force balance question. N equals m omega square r, and F will equal mg. So F equals mg and N equals m omega square r. Now, because they ask the minimum coefficient of friction, the friction coefficient between the surfaces, when they are asking make it as small as possible, what that indirectly means is that the friction's value is as max as possible, maximum friction. Okay, so what is the maximum amount of friction that the surface can support? It is the limiting friction. So that friction force limiting, we know it is equal to mu n. So that's all we have to do. For minimum coefficient of friction, all we have to do is make the friction limiting. Okay, max possible value of friction. So F, we will put it equal to mg, and this will be equal to mu minimum times the normal reaction, which is m omega square r. Okay, so now we just have to solve and find mu minimum. So the answer will come out to be 0.1 in this case. Okay. Yeah, it's totally fine. Okay, so I'm not doing the exact calculations for this lecture, mainly doing only the logic behind the questions. Okay, I'll mark the answers for you guys. You guys can later get the PDF and resolve it and check the answers for yourself. Okay, so yeah, next question is from electrostatics. These are also from the April attempt. So the question is, we have two spheres that are connected with a conducting wire. Okay, so when we connect two conductors with a conducting wire, what happens is that the potentials of the two spheres become equal, right? So if I say, there is also another information that it's not given in the question, and that is these spheres are far away. Okay, they are not close to each other, because as these are conductors, right, if they come close to each other, they can influence each other's charges. Okay, so like for example, the surface charge density can be different if you bring them close to each other. That's why, to avoid any interactions, we keep the spheres much far away. That is not mentioned in the question, but yeah, that should be kept in mind. So yeah, once we connect the conducting wires, the potentials become equal, right? And the question is, what is the surface electric fields? Okay, so this is a formula based one, another formula based question. E1 are surface. Okay, so we'll just say, so is something else given. Two spheres are connected with a conducting wire. ES1 and ES2 are the electric field at the surface of the sphere. Okay, so which means if I say the charge on this sphere is Q1 and this sphere is Q2, then we can say Q1 divided by 8 centimeters equals Q2 divided by 18. It's a potential formula, right? KQ by R. So Q1 by 8 equals Q2 by 18. So with this we get the charge ratio. Okay. Now the electric field at surface 1 divided by electric field at surface 2 is KQ by R1 square divided by KQ2 by R2 square. So this will be Q1 by R1 square divided by Q2 by R2 square. Okay, so now we have charge ratio as well from here. So we can easily solve it now. Okay. So the answer, you guys can, confirm it later. It will be 2.25. Okay. Yeah, good night, Karthik. All the best. Yeah, you can watch it tomorrow. Okay, so this question was mainly, the logic is that if we connect it with a connecting wire, the potentials become the same for the spheres, and this is the formula for that. After that, we know the surface electric field. At the surface, the electric field will be KQ by R square. Okay, and then we compare it. All right. Okay, so now we have buoyancy, question on buoyancy. A wooden cubical block of relative density 0.4. So relative density of any object, okay. Relative density just implies the density of that object divided by density of water. What is the density of the object relative to water? So that is what relative density means. It's floating in water. Side of the cubical block is 10 centimeter. Now the question is, when a coin is placed on the block, it dips by 0.3 centimeter. Weight of the coin is. Okay, so this question is also April shift one. So let's say this is the water surface. A cubical block is floating on inside the water, something like this. So first thing is its relative density is given. This relative density tells us something useful. So let's say the submerged part has a length of x. So first let's do the force balance on this, ignore the coin for now. So what is the mass of or the weight of the cube? It will be density of the object times the volume of the cube, right? Volume, I'm going to write it as side length into base area, okay? Rho V times G. This is the weight of the cube. Now what is the buoyancy? The buoyancy would be the buoyant force would be the submerged volume, which I'm going to write it as x into A, times the density of the liquid, which will be rho W into G. So this was the initial situation. We have buoyant force upwards, weight downwards. Once we equate it, we get density rho of the object times A equals rho of water into x. Okay. So what is rho divided by rho W? It's the relative density. So the relative density is also equal to x by A. What is x by A? X by A is the fraction which is dipped in water, right? So if relative density is also given as 0.4, which means the fraction that is dipped is 0.4 that of the total length. So if this length is 10 centimeter, the fraction that is dipped is 4 centimeter. Okay, this is given to us. This is a useful information that the relative density gives us. So if relative density of the cube is 0.4, that means 40% of the cube is underwater. Okay, so that's the first thing. Next is we place a coin on top of this cube. Okay, so we keep a coin on top of this cube. Now the coin will have some weight, and because of that the cube will dip down further, and that dipping amount is given. It dipped down further by 0.3 centimeter. So now the question is straightforward. So let's just say that extra amount dipped. We'll use a different color for that. So let's say this is that extra volume that was submerged. Extra volume of the cube that was submerged because of placing this coin. Now this coin's mass, let's take it as small m. Okay, so I'm saying its weight is mg. So now the cube's equilibrium remains the same, right? The cube's weight mg and the already submerged volume buoyancy, they cancel each other out. Now this mg weight, this has to be balanced by the buoyant force itself, and that extra buoyant force is given to us by this extra volume that was newly submerged. So that is the only thing we have to do. This extra amount which was dipped is given to us, this 0.3, let's call it y for now. So what is that extra volume submerged? It will be that y times the base area A. If I multiply density of water into G, this will give us the extra buoyant force. Extra buoyant force. Okay, and this extra buoyant force will be equal to the weight of that coin, which is mg. So this is the main concept. And weight of the coin. So this is what you have to find. So that will be density of water into y into base area into G. So that is it. So are you from? Yeah, that I am from. That is my channel. Yes, Air Force. Yeah. This is a April shift question. April shift question only. So the answer would be 0.3. Yes, that is correct. Answer is 0.3. So you didn't have to do any of this. This is just me explaining. The extra buoyant force is equal to the weight of the coin. That is it. So this y is given to us 0.3. This will be 0.3. Base area of a cube is 100 centimeter square. Convert it into SI units. Density of water is 1000 and G is 10. Okay. That is it. Now this is a magnetism problem. We have to find the ratio of magnetic fields at the center of the semicircular part. Okay. So this is an infinite wire, semi-infinite wire. So due to a semi-infinite wire, I guess the magnetic field at a perpendicular distance of r, this formula is probably known to you. If you have a semi-infinite wire, the magnetic field at a perpendicular distance d, use right hand rule, that will give us the direction, it will be into the page, and the magnitude is mu naught I divided by 4 pi d. Okay, the general formula was sine alpha plus sine beta, and one of the angles you will set it equal to 90 and the other will be 0, right? So it will be mu naught I by 4 pi d for a semi-infinite wire. So due to this wire, we'll have an inward magnetic field at O. Okay, and similarly due to this wire also you will have an inward magnetic field. Both will have the same magnitude of mu naught I by 4 pi d. So due to this, it will be twice of this, the wires, straight wires, it will be twice of this, which is mu naught I divided by 2 pi d, and due to this half ring, you could say the magnetic field at the center will be mu naught I by 4r. Okay, due to the total ring, it will be mu naught I by 2r. Due to the half ring, it will be half of it. Similarly, over here, the only difference is that due to this wire, there won't be any contribution at the center, right? Why? Because the wire directly passes through the point O. So due to this wire, no contribution. Other than that, everything remains the same. Okay, so that was this problem. This is also an April shift one. You guys can confirm the answers later. It will be option A. Okay, all right, moving on. So object is placed at 40 centimeters. So this is a spherical surface refraction problem. Some of you guys asked me about the formula revision, right? So I would say just write down the formulas while watching this lecture itself, because we'll cover a lot of formulas. So you can just mark it down in your notes while attending this lecture itself. So yeah, object is placed at 40 centimeters. So object distance is given to us, right? Radius of curvature is 20 centimeter. We have to find the height of the image formed. Okay, so this will include the magnification formula. So yeah, so firstly, it's a simple spherical surface refraction formula itself, right, which is mu2 by v minus mu1 by u equals mu2 minus mu1 divided by r. So what will the sign convention be? Right side is positive. So from the optical center, everything to the left is negative, everything to the right is positive. So object distance, we would put minus 40. So u will be minus 40. Image distance is the unknown, we will solve for it. Radius of curvature, because it lies to the left of the optical center, it will be substituted as minus 20. And after that, mu1, mu2, everything you will substitute, and you will finally solve for v. Okay. And then once we get v, because the question asked us the height of the image formed, we can use the magnification formula, right? The magnification formula, you should remember this for the spherical refraction case. It will be n1 by n2, or we should use mu1 by mu2 multiplied with v by u. Okay, so v by u was the formula for the convex lens case, right? With that, we just multiply mu1 by mu2. Now, mu1 is the refractive index of the medium in which object is kept, right? And mu2 is the refractive index of the medium in which image is formed. So just remember that while writing down the formula. Pathfinder explanations, okay, that helped you, great. I'm starting class 11 physics, suggest me books other than HCV and NCRT. So books, it depends on what you need them for. Are you talking about for practice or theory reading? Do you teach in any paid batch? So my batch will start on 11th, not 11th, 13th April in Arjuna. So it will be for 11 students. And start, yeah, so I mean books, the issue with books is there are a lot of books written for JEE mainly. And in the JEE books, what happens is they throw thousands of problems inside that book. And the thing is it doesn't clearly explain the concepts. But then there are theory books which explain the theory beautifully, but there are no problem practice, right? So yeah, one shot. It will be till 2 a.m. You can join in or you can go to sleep if that ruins your sleep schedule. So yeah, let's move on. This question, I guess it is clear. It's a formula based question. So this is the spherical surface refraction formula. This is the magnification formula. Okay, these are important. Yeah, you should sleep. Yeah, Aniket. All right. Oh yeah, the answer for this question will be 0.96. Okay, you can confirm it. So next is satellite revolving around a planet of mass 2m, okay, in an orbit of radius r with time period t1. So time period, mass, radius of the orbit. Then we have another satellite. The important thing is this is a satellite of a different planet. It has a different mass in an orbit of radius 2r with time period t2. So now because the masses of the planets are different, you cannot use that formula t square proportional to r cube, right? Because the satellites are satellites of different planets. This formula is for when for the situation when we have the same planet, right, of mass m, and we have let's say first orbital radius r1, and thus let's say second satellite is at an orbital radius of r2. Then you can use this formula to compare their time periods, okay? But because the masses are different, in this case, you cannot use this formula, okay? So for this, there is a general formula which we discuss, the actual time period formula in the circular orbit, and that formula is 2 pi by square root gm times radius to the power 3 by 2, okay? So this is the time period of the satellite when you actually derive it. Who should take a drop? Okay, that is a complicated question. It's mostly a personal preference. Like if you think you like the subjects and you love studying it, and if you think you can keep studying for long hours for a whole year, I mean, it's a personal decision, I would say. Like I also took drop at my time, and but at that time I really liked physics, so I wanted to study it for a whole year, and it was fun for me. That's why I took drop. It's a session. Yeah, if you have a session, you don't have to watch that. That will just stress you out, I would say. You can go sleep if you should try to sleep. Parents, oh yeah, that is a different issue. Yeah, you should try to convince, maybe, I don't know. Okay, so yeah, now once you know this formula, you can just take the time period ratio, right? You have the mass of the planet here, radius here, everything is given, t1 by t2 you can do, okay? After that it's a, yeah, I am from IIT Madras. One second, I'll tell you guys the answer. The answer will be third option, half, okay? All right, next problem. So parallel plate 1. So parallel plate capacitors are constantly appearing, okay, where we include a dielectric in between. So this is an easy question. So in dielectric constant is given, we have to find what is the increase in capacitance, okay? So firstly, you write down the capacitance of this, right? It will be epsilon naught A divided by D. This is the capacitance in the first case. In the second case, we included a dielectric of dielectric constant 5, okay? And now this dielectric plate and this air capacitor, we will treat it as two different capacitors in series, okay? So their equivalent combination, we will draw something like this. And the first one, we will call it it is the dielectric capacitor, and that we can write it as epsilon naught times you know, the dielectric constant. I'm just writing it as epsilon r for now. Epsilon naught epsilon r d. So here the d distance is d by 2. Sorry, it was epsilon naught area. So area is the same for both the plates, epsilon naught a divided by d by 2. And the air capacitor, it will be epsilon naught area divided by d by 2. Both of them have width as d by 2. And now for the series formula, you can do C1 C2 by C1 plus C2. And once you do that, you will get a C final here, right, for this case. And let's say this is C initial for this capacitor. How do you find the percentage increase? That is just delta C divided by original capacitance into 100, right? So yeah, the answer you guys can later compare. The answer will be 66.67%. This is the percentage increase in capacitor. Okay. Is it half? Are you asking for the? Yeah, it is half. It will be 2 a.m. Yeah, till 2 a.m. Important ones. Yeah, I'll tell you guys what will be the important ones. So net electric field at point A. So yeah, we have two dipoles, 2 point dipoles like this. P1 pointing to the left, P2 pointing upwards. They have given the net electric field at point A, which is a point over there. This distance, take it as R. We have to find the net electric field at A is given to have an angle of 60 degree with the x-axis. So we have to find the dipole moment ratio. Okay, so these are based on standard results once again. So P1, point A is along its axis, right? So along the axis, the formula for electric field is 2 kp by r cube, right? So, and that will be along the dipole direction itself. So that will be this red arrow. That will be to the left, okay? And what is the magnitude? The magnitude is 2k, dipole moment is P1 divided by r cube. So this is the dipole moment electric field due to this P1 dipole. Due to this P2 dipole, the point A is in its equatorial plane, right? So the electric field will be minus kp2 by r cube, which means it will be downwards. So due to the second dipole, it will be in the downward direction, in this direction, okay? What is the magnitude? It will be kp2 by r cube. So this is the electric field due to P1, this is the electric field due to P2. Their resultant vector will give us the net electric field. Okay, and let's say this is the net electric field. What's provided in the question is that it makes 60 degree with the x-axis. This angle is 60. Okay, so now you can write down tan 60. This will be P2 divided by 2P1. P2 divided by 2P1. There was a printing error here. I guess this was P2 by P1. Okay, so P2 by P1 will be 2 times root 3. Okay, so this was actually P2 by P1, but it doesn't matter. Like the conceptually, it's the same. So the answer is 2 root 3. Okay. Actually, there are some topics that constantly reappear. Solve gravitation question completely. Okay. Yeah, so here if I want T1 by T2, so root m is in the denominator, so this will become square root m2 by m1, and that will be r1 by r2 whole raised to power 3 by 2. I'm just taking the ratios, T1 by T2. So the 2 pi constant will cancel off, root g will cancel off. So this will become, yeah, it's correct. So m2, the mass in the second case is 4m, first case is 2m. So this will become root of 4, so this will be root 2, right? And r1 is r, r2 is 2r, so this will be half to the power 3 by 2. So that I can write it as 2 root 2, right? 3 by 2 I can write it as 1 plus half. So 1 is 2, 2 to the power 1 is 2, 2 to the power half is root 2, this cancels off. Okay, so half. Yeah, if you're scoring 98.53, I mean, drop, should you take a drop? If that's a personal decision, but it's a great score and you can definitely improve a lot within 1 year. Not hoping any improvement. Okay, that was in Jan. Yeah, it was not P1 by P2 actually. It was a printing error. It's P2 by P1 and that will be 2 root 3. All right. Next problem, angular momentum of an electron in a hydrogen atom. This formula is the Bohr quantization rule. Most of you may remember it. MVR equals NH by 2 pi. So MVR is basically the angular momentum of the electron itself. So if it is NH by 2 pi and if you compare it with that, you can see the orbit, it is in the third orbit, third energy level, right? Energy of the electron in that orbit. So this is another standard formula. The energy in the nth orbit is minus 13.6 hydrogen atom. So Z is 1. So 1 by n square. So now you can put n equal to 3 here. N equal to 3 here. So yeah, you're right. It's 1 minus 1.51 electron volts. Okay. Yeah. This is also April shift. This one is also April shift. Equation of a plane progressive wave. So equation of a traveling wave is given to us. So yeah, these questions as you can see are very easy. X and Y are in centimeters. Okay. You have to find the wave velocity. And the thing is, the wave velocity should be reported in meters per second. This was the question. Okay. Yeah. So wave velocity is simple. It's a standard formula once again. It's omega divided by k. So omega is the coefficient of t, which is 200. K is 1 by 150, right? So this will be 1 divided by 150, which is 330,000. But the thing you need to remember is this is in centimeters per second because x and y were in centimeters. So this will be centimeters per second. So if you convert it into meters per second, the answer will be 300 meters per second, and this is what you had to report. Okay. All right. Let's move on. Lithium 2 plus converted into lithium plus 3 plus electron. Energy required for this process. So basically they're asking the ionization energy. How many hours? It will be till 2 o'clock maximum. Let's see if we can complete it before that. So yeah, they're asking the ionization energy. What is the energy required to remove an electron? What they have given is the ionization energy for the hydrogen atom. So ionization energy, you can say it is the energy that it takes to, so if I have a hydrogen atom, I know the ground state energy is 13.6 electron volt. So I have to supply 13.6 electron volts to remove this electron. Okay. Yeah. Hopes. Yeah. XYZ questions will appear. These are all April shifts one only. So yeah. So what is? So we just have to find the ionization energy for lithium. So for lithium, we know the nth energy state formula, right? It's minus 13.6 Z square by n square. So for lithium, we'll just have to put Z equal to 3. So that will be minus 13.6 times 3 square 9. Okay, so this will be the ground state energy for lithium. Okay, and this is the energy I have to supply to that electron in ground state if I want to remove that electron. So that will be the answer in positive sign. So I guess it will be first option if you multiply it. Yeah. Yeah, it will be the first option. It's basically you have to supply the ground state energy of an electron to that electron, and then you will be able to remove that electron. Okay, yeah, first option. Next question, you guys can try it. Okay, electric field of electromagnetic wave. So there is a slight issue with this question. This is also April shift question. Now I don't know if it's the mistake with NTA or the issue with the translator who wrote this question. So the issue is the electric field is given, but the direction is not given, right? So looking at this expression, we can say that the wave is propagating in the -x direction, but we don't know in which direction is electric field or in which direction is magnetic field. So the question, if we read further, they are saying a charged particle is moving with a speed of this much. We need to find the ratio of magnetic force to electric force. Now we cannot find that without knowing in which direction is the electric field and magnetic field, right? Sir, will you be in any batch, in the AY batch? What is the AY? I will be teaching in Arjuna JEE for 2027. Okay. Yeah, so I guess you guys got the issue with this question. We don't know the direction of electric field and magnetic field, but I am assuming the electric field, let's say if it is in Y direction, okay, the magnetic field will be in some plus or minus Z direction. As the electric field, I mean as the wave is along the -x direction, right? So electric field, magnetic field and the wave propagation, they are all perpendicular. So if let's say this is the direction of the electric field and this is the direction of the magnetic field, and if the electron or the charge that is given in the question, it must be along the electric field's direction. If this was the case given, then only we can use the formula QE for the electric force and QVB for the magnetic force. Okay, so I guess if you check the solutions, how they did this was write the electric force as QE and the magnetic force as QVB, but that is only possible in this case. Right, because it matters in which direction you project for the magnetic force. The electric force you can still write QE, but magnetic force, it will be 0 if you project along the magnetic field direction. So it depends on the direction. Okay, but this should be the condition which NTA I guess assumed, right? Because a lot of solutions, if you see, they wrote QE as electric force and QVB as magnetic force. But QVB you can only write if the velocity of projection is perpendicular to the magnetic field, right? Otherwise it will be QVB sine theta. Okay. All right, next question. Oh yeah, so if you do that formula, the answer will be (10⁻²). Okay. Work function problem, where the work function of an object is given, of a surface is given, 2.3 electron volts. Maximum kinetic energy of ejected electrons. Maximum kinetic energy has a standard formula, K max. It's the energy of the incident photon. So here wavelength is asked, right? So we can write the formula hc by lambda. Wavelength of the energy of the incident photon minus the work function. Okay, so hc we can use the formula 1240. This is electron, in electron volts you will get the answer. Electron volts nanometer is the unit, divided by lambda. This is equal to K max was 0.18. 0.18 plus 2.3 will give you 2.43. Okay, so now if you solve it, you will get the answer as 500. Okay, lambda value 500 nanometers. Yeah, it is equal to wave velocity, Sagnik. Okay, next question. Binding energy per nucleon is given. Mass of the bismuth nucleus is given, and it is given in AMU. Mass of proton, mass of neutron is given. 1 AMU to conversion to mega electron volts is given. We have to find the binding energy per nucleon. Okay, so first step is to find mass defect in problems like these. So for mass defect, we need the number of protons and the number of neutrons. Okay, so looking at this structure, we can say the mass atomic number is 83. So number of protons is 83, and for number of neutrons, you can subtract it from the mass number 209. So it will be 126. Okay, so as we determine the number of protons and number of neutrons, now we can find the mass defect. So number of protons is 83 times mass of one neutron, Mn, plus, now the number of protons is 83, no, number of neutrons was 126. So times mass of neutrons plus number of neutrons is 83 protons times mass of one proton, and then you subtract it with the mass of the bismuth nucleus. So capital M Bi. Once you solve this, you will get the mass defect delta M, and delta M will be in AMU, right? So to convert AMU into mega electron volts, what you will do is convert this, multiply this value with 931, and you will get the binding energy in mega electron volts. Okay, now once you get the binding energy, total binding energy, all you have to do is divide it with the mass number, total number of nucleons, which is 209, and this will be the binding energy per nucleon. Okay, so the answer after calculations will be 4, which is 7.64 something. Okay, yes, XYZ, that is correct. So this question is simple. Mass defect times 931 will give you binding energy, total binding energy of this bismuth nucleus in mega electron volts. Now they want it per nucleon, so you have to divide it with the number of nucleons. That will give you the answer. Okay. Next question, speed of 1 kg object when it reaches closer to Earth's surface from long distance after it is released from rest. Okay, so here initial velocity is 0. So, and we want this mass to reach close to the surface of Earth, which means its final radius will be capital R, radius of Earth, final distance. So initial distance is far away. Okay, so the answer for this will just come out to be the escape velocity, right? And the reason is, that's how we derive the escape velocity, right? So when we derive the escape velocity, we project the object with escape velocity, and the initial situation is the object is at radius r, kinetic energy is half mv square, and the final situation is velocity is 0 and it is at infinitely far away. So it's the same derivation as the escape velocity. So therefore, if you solve this problem, you will get the escape velocity itself, right? It's just a reverse problem. 931.5, yeah, that will be given only, so you don't have to worry about that. Okay, so next problem. Moment of inertia about an axis AB is equal to moment of inertia of solid sphere about the axis parallel to AB. So in these two situations, the moment of inertia is the same. So you have to find R. Okay, so this is an easy question. Moment of inertia of a rod about that axis is ml square by 3. Right, this is the answer for the rod, and for this is going to be solid sphere. So this, for this it is 2 by 5 mr square. and you just have to equate them. So even this question is from April attempt. Okay. Previous question repeat. Yeah. Actually what I meant is, like, if you have done the derivation for escape velocity, how we derive it is, first we assume that we throw the object with escape velocity. So the initial kinetic energy is half m escape velocity square. Initial potential energy is minus g m small m divided by radius of Earth. And in the final situation, we assume the mass to have zero speed, right? It is far away from Earth, and its potential energy will also be zero because the r tends to infinity. So this was the derivation of escape velocity formula. What this question is just the opposite of it. So here we start from a point that is far away and speed zero. So which was the final case in this situation, and then we wait until Earth attracts it and the body reaches the surface. Okay, and when it reaches the surface, this is the situation, half mv square final velocity minus gmm by r. So it's the same formula is what I meant. Okay, both are the same problems. So if you do mechanical energy conservation in this case, you will just get the escape velocity itself when it reaches the Earth. Okay, so yeah. So this question I'm skipping because it's too easy. The answer will be 60 for alpha. The answer will be 60. Okay. All right. Surface tension of soap bubble is given. Work done in increasing the diameter of the bubble from 2 to 6. So this is just a surface energy. We have to use surface energy logic here. The main thing to keep in mind is that we have a soap bubble here. Okay, so initial surface energy will be, we have to include a 2 here because we in the soap bubble we have to consider the 2 surfaces. So if you zoom into the thin film of the soap bubble, it will have a liquid layer inside, air outside and air inside. Okay, so this air liquid surface is considered one of the surface and the inner one is considered another surface. And this is the actual structure of the bubble, okay, even though this is actually very thin. So when you are writing the surface energy for bubbles, you have to include this factor 2, otherwise you will get the wrong answer. Okay, so 2 times surface energy, surface tension T times the area of the bubble. So I'm not substituting anything, I'm just writing the formulas, 4 pi r1 square. This will be the initial surface energy of the first bubble. And in the final situation, what will happen is the same factor 2, surface tension 4 pi r2 square. Okay, now surface energy depends on the surface area. So greater the surface area, greater the surface energy, which means if you do delta U, the answer will come out to be a positive answer. And that is the work that we have to do to increase the area of the soap bubble. Okay, you can think of like you have to blow the bubble to increase its radius. So we have to perform that work. Okay, so you just have to do UF minus UI. So delta U will be simply UF minus UI. Okay, this question is one of the very important ones. Okay, this actually appeared in all shifts of April. I just recorded a video before this session based on this topic. This topic is constantly reappearing. So you might just get a question from this in your shifts. Just remember that if it's a soap bubble, include this 2. If it's a liquid drop, just include a 1. Okay. All right. Moving on. Bohr model hydrogen atom. Magnetic field at the center due to electron in the second orbit is B1. Magnetic field due to the electron in the fourth orbit. So we have to talk about magnetic field. So Bohr atom, and so firstly we have a in the Bohr atom model, what we have is a electron revolving in a circular orbit, right? So let's say that radius is r. This is also a standard formula. The derivations are usually done. So if the velocity of the electron in this orbit is v and the radius of the circular orbit is r, magnetic field. So we compare it to this situation where we have a current carrying circular ring, right? And because of this I, the magnetic field at the center, if you use right hand rule, it will come out of the page, which is a dot, and this magnetic field is mu naught I by 2r, right? So we are drawing parallels to this. So what is this? This is an electron rotating in a circle, right? So this is moving charge, so it will contribute a current, okay? And the way we calculate that current is we take a circular cross section somewhere, and we will try to find out how often does this charge cross this cross section, okay? So the average current, we will define it as delta Q by delta T. Okay, so what is the charge that is moving? It is one electron, so it will be E. And let's say the electron E was over here, okay, and it crossed this cross section. What is the next time after which the electron comes back? It is equal to the time period of the circular orbit, right? And time period in a circular motion is 2 pi r distance divided by speed v. So delta T will be 2 pi r divided by v. Okay, and this formula is usually discussed in class. So if you have an electron in a Bohr orbit, the average current, right, you can think of this like a current flowing like this case, and that current is going to be EV divided by 2 pi r. Okay, and because of this current, the central magnetic field, we can write it as mu naught I by 2r. Okay, so the magnetic field, we can say it is mu naught times that current I, which is EV divided by 2 pi r. This is the current part, mu naught I divided by 2r. Okay, so this will be, actually we need the ratios, right? So we can just write the magnetic field is proportional to velocity divided by r square, because everything else is just a constant, right? So if when we take the ratio, that will get cancelled out. Okay, so now this is also something that you should keep in mind. The velocity has a dependency on z and n, okay, and that is the velocity is proportional to z by n, okay, where z is the okay, so I guess you guys know this formula. N is the number of the state, okay, so and the radius is proportional to n square by z. Okay, so this is how radius and velocity of the electron is dependent on z and n. Okay, so I guess you guys know these formulas, these relations. Okay, why am I writing this? Because I want how is magnetic field related to z and n. In fact, we don't have to write z because it's hydrogen atom, right? Z will be 1. So V divided by R square. Magnetic field B is proportional to V. V is proportional to Z by N divided by R square. R is proportional to N square by Z. So R square will be proportional to N to the power 4 divided by Z square. Okay. So now we will just get magnetic field is proportional to 1 divided by N to the power 5. I'm ignoring Z because here we have the same atom, right? Same hydrogen atom. So yeah, I guess this would be it. Okay, so is this clear, guys? Okay, so are the calculations correct? Let's see. Velocity is proportional to Z by N. Z by N. R is proportional to N square by Z. So N to the power 4. Yeah, seems fine. B1 is the field due to the electron in second orbit, so N equal to 2. And B2 is the electron in the fourth orbit. So B1 by B2, if we do, it will be 2 to the power 5, right? So 2 to the power 5 should be 32. It's correct. It's 32 itself. The answer will be 32. Okay, so now just take the ratio B1 by B2, it will be 2 to the power 5. Okay, so next question. Find potential difference across the bulb, across this bulb. Rated power is 100 watt, rated voltage is 200 volt. You have to find the potential difference across that bulb. Okay, so power rating and voltage rating is given. So with that, we can find the resistance of the bulb. Okay, so power equals V square by R. So using this, we can find the resistance of the bulb. So 100 equals divided by R. So resistance of the bulb is equal to 400 ohms. Okay, so this we just figured out using the power rating given and voltage rating given. Now if the bulb, just replace it with 400 ohm resistance, this 400 ohm and this 400 ohm is in parallel, so their equivalent will be 200 ohm. That 200 and this 200 is in series, so 400. So current will be V by R, so 100 divided by 400, which is 0.25 amperes. Okay, so now once we get the current, we can find the potential difference easily over across this terminal. So this 0.25 passes through this 200 ohm resistance. So if you do IR, what will it be? So it will be 200 times 1 by 4, right? 200 times 1 by 4. So this is going to be 50 volt, right? So if the potential across this is 50, then the potential across this is also 50. Actually, these two are same resistances, right? So this is 200, this is also 200. So it will be equal split of 50-50. So the answer will be 50 itself. Okay. Okay, I will speed up. Yeah. There is a layer of refractive index mu above the base, below the base of the equilateral prism. So this is where mu is. Okay. The path of a ray is shown in the figure. Okay, so this is the path. So firstly it intersects perpendicularly, then it goes parallelly to the base. Okay, so this is the critical angle case. So this will be the critical angle, right? When it is intercepted at critical angle, the ray goes parallel to the surface, or you can also say the emergent angle is 90 degree. So now we just have to use Snell's law once, right? So mu is 1.6 sine theta c equals, here mu is mu times sine 90, which is 1. So now there is a thin layer of refractive index mu, the path of a ray is shown, find out mu. Okay, so which means the angle theta must be given, right? So this is a equilateral prism. So which means if this is 90 degree, this is 60, this will be 30, which means this will be 60 degree, right? Because it's an equilateral triangle or equilateral prism. So which means theta c is 60, sine 60 is root 3 by 2. This will be equal to mu. And if you do calculations, the answer will be 1.38. Okay, so yeah, let's speed up. Okay, so now in this question, logic gate is given. So I guess there was some mistake in this question. Not all of these were NAND gates, but let's just solve it as if all of them are NAND gates. Okay, so if input A goes through this NAND gate and there is also another A will just become not A, right? So the output from here will just be not A, which is A bar or A complement. Similarly, B's output here will be B complement. Now A complement, B complement. Firstly, this is also a NAND gate. So first let's do A complement dot B complement. This is what AND gate will do, but because it is a NAND gate, it will be a whole conjugate, right? So, and this is simply equal to A plus B. This is like De Morgan's law, okay? And Now the thing is, what we have over here after being processed by this NAND gate is A plus B. Okay, now once the A plus B becomes processed by this NAND gate once again, this will be A plus B the whole conjugate. Okay, and what is A plus B the whole conjugate? A plus B is the output given by a OR gate. So A plus B the whole conjugate will be the output given by a NOR gate. Okay, all right. So yeah, mutual inductance problem. So we have a square whose length is L and R is significantly smaller than L. So this diagram is a bit wrong. Situation will be something like this, where we have a square and this ring in the middle is tiny. Okay, so the radius of that ring is significantly small compared to the length of the square. We have to find the mutual inductance of the system. So mutual inductance is a very standard process. So the first step is to ignore this ring and find the magnetic field due to this square, current carrying square, at the center. Okay, ignore that this ring is huge, the ring is very tiny at the center. Okay, so what we'll do is we'll find the magnetic field due to this square at the center of this square. Okay, so that is a standard exercise. So if we have one current carrying wire like this, then we have to find the magnetic field here, right, at a distance of L by 2. If the current is being carried in this direction, direction will be given by right hand rule, so into the page, and we can find out this angle, these two angles. For a square this will be 45, right? These two angles are 45. Now we'll apply it into the standard formula. The standard formula is magnetic field over here will be mu naught I by 4 pi perpendicular distance, this is L by 2, times sine of 45 plus sine of 45, sine alpha plus sine beta. This is the magnetic field due to one of this wire. Now because there are 4 wires and all of them are symmetrically arranged, net magnetic field will be multiplied with 4. Okay, once you do this, you will get the net magnetic field at the center of this square. Okay, the center of the square. Okay, now why are we doing this? We are doing this because the tiny ring, the ring that we are talking about, it's a very small ring that is placed extremely close to the center, exactly at the center, right? So we will assume because the ring is so small in radius, the magnetic field does not change much within this ring. Okay, so we will consider the magnetic field in this region to be a constant magnetic field, and its value will be equal to this value, whatever that value may be. Okay, so now if we zoom in into that ring, we'll have a ring and we have an inward magnetic field B, okay, which we'll consider it as constant in this area. Now we can find out the flux of this magnetic field. It will be equal to the magnetic field B times the area of this circular loop, which is pi r square. Okay, now once you find out this flux, compare it with flux equals mutual inductance times the current I. Okay, like this magnetic field will include I, which is the current through that square. So if you substitute that over here, the current I cancels out and you will get the mutual inductance. Okay, so this is the standard process of finding the mutual inductance. So yeah, first step is finding the magnetic field at the center. This can also be a square loop, like instead of this small ring at the center, it can be a small square. Okay, in which case same process you will do. You will find the magnetic field at the center. You will assume that it's constant within that small square, and basically the only difference is that the flux, instead of the pi r square here, you will include a square, in which a is the side length of the small square. That is the only difference. Then you compare it with phi equal to mi and you will get the mutual inductance. Okay, so once you solve it, the answer will be option 4. Okay, all right, next question. YDSE problem. YDSE experiment intensity is 3/4 of the maximum intensity at point P. The path difference at point P is delta x equals lambda by A alpha. Find the value of alpha. So it's given that at P the intensity of the interference pattern. So after these two light waves from slits intersect at this point, interfere at this point, the resultant intensity is 3/4 of the maximum intensity. So the formula once again, the intensity, if we know about this angle theta, the intensity formula is 4 I naught cos square phase difference divided by 2. Okay, this is the formula for finding the intensity of the interference pattern formed by two waves like this, if the phase difference between the two waves is delta phi. So it is given it is 3/4 of the maximum intensity. Now maximum intensity is 4 I naught, 3/4 of 4 I naught is 3 I naught. Okay, so from here cos square is 3 by 4, cos is root 3 by 2, which means the angle delta phi by 2, when is cos root 3 by 2? 30 degrees, right? So this will be pi by 6. Okay, so the phase difference between the two waves is pi by 3. Now once we have phase difference, what is asked is the path difference. Okay, what is the relation between them? The path difference multiplied with the k value, wave number, this is equal to phase difference. Okay, delta phi. Delta phi is k delta x. So from here we can get the path difference. These are all formula based problems only. Pi by 3 is the phase difference. K is 2 pi by lambda. Lambda is probably given. No, they want the answer in terms of lambda. So this will be lambda divided by 6. B option. Okay. Yeah, B option. Next question, epsilon naught is the permittivity of free space, phi is the electric flux. So yeah, this is a dimension problem. It's for you guys. You guys can comment the answer below. If you guys recognize what that quantity is, you can get the answer. Type the answer in the comments. Let's see. All right. Yeah, so this will be the displacement current, if you guys have remembered it. So we learn it in the chapter of EM waves, right? Over there we discuss what is the displacement current. So this will have the same units as current. So the dimension would be the same as current. Okay. Cubic block, mass m, sliding down an inclined plane at angles 60 degrees with acceleration g by 2. What is the coefficient of kinetic friction? So an FBD problem. So the inclined plane's angle is 60. Acceleration downhill is g by 2. Okay, so now it's a straightforward problem. So this will be mg sine 60, and upward we have mu mg cos 60, and you guys can do f equal to ma. Okay, so I'll give you the answer. The answer will be root 3 minus 1, first option. Simple f equal to ma problem. Next question, rod of 5L is bent at right angles, keeping one side as 2L. The position of the center of mass of the system is. So we have L-shaped rods like this, uniform mass distribution. So this 3L part will have 3m mass, 2L part will have 2m mass. We have to find its center of mass coordinates. Okay, so it's a direct formula based. So the coordinate of the center of mass We will write it as m1 r1 vector plus m2 r2 vector divided by m1 plus m2. Okay. So here this 3m mass, we will consider it as one mass. Okay. And the center of mass of this 3m mass, we will place it at 3l by 2 distance along the j cap direction. Okay, and this 3l mass, we'll consider it as 3m. Okay. Similarly, the 2l mass, we will place it at 2m distance. No, it's 2m mass, we'll place it at half 2l, which is l distance. So these are the two masses and these are the two coordinates of them. So we'll substitute it as vectors. So m1, let's say it is the 3m mass. Its position is 3l by 2 j cap. 3l by 2 j cap. And m2 mass is 2m. Position is l I cap. Divided by total mass, which is 3m plus 2m, 5m. So this will be 9 by 10 j cap, 9 by 10 L j cap plus 2 by 5 L I cap. L was given to be 10 centimeters. So this is going to be 4 I cap plus 9 j cap. This will be the center of mass coordinates. Okay. Next question. So the long question, two blocks are given. Block A moves with constant speed of 3 meters per second. So this V is 3 meters per second. Towards the other block, spring with spring constant K is attached with block B. After the collision, suppose that block A and B along with the spring in constant compression state. Okay, so this block will hit the spring and the spring will compress, and then B will also start moving, right? All the blocks move together. Now together means they move with the same velocity. Okay, then they are asking in that state what is the compression in the spring. Okay, this is an energy conservation and momentum conservation problem. So I'm taking balls instead of blocks. Okay, so we have the spring here. This is m2. So so this initial situation is m1 had some velocity v. Okay, and finally what would happen is m1 will compress the spring and we'll have m2 as well. Now once the spring gets compressed, m2 will be pushed to the right, so m2 will also accelerate. And the final situation, it's given that both of them move with the same speed. Okay, so let's use the symbol Vf. Okay, now what we'll do is, because it's only internal forces acting in this question, if we take m1 and m2 together, there will only be the spring force acting, which means we can conserve momentum along the x direction. Okay, so initial momentum is m1v and final momentum is m1 plus m2 into vf. Okay, with this equation you can find vf. This is a momentum conservation equation, and now you can use energy conservation. So let's just say the spring compression is some x. So initial kinetic energy is half m1 v square. Finally it is half m1 vf square plus half m2 vf square, and the spring compression will be half kx square. This is the potential energy stored in the spring. Initial energy equals final mechanical energy. That is it. Okay, so with this you can solve for x. That will be the answer. That is what is asked in the question. So, okay, the answer will be option 3, 0.1 meters, once you confirm it. Next problem is a rolling motion problem. We have a force 49 Newton tangentially acting at the highest point of the sphere over here. We have to find the acceleration of the center of mass. Okay, so we have to find ACM. So there will be some friction acting on the sphere because it's rolling, right? And there will be a normal reaction passing directly through the center of the sphere, and there will be mg as well. So in rolling motion, if you have studied this topic, we use ICOR, which is the point on the sphere which is in contact with the ground. We use this point to write down the torque equation. Okay, so of course this cylinder is going to, not cylinder, sphere, right, solid sphere, this is going to rotate with some angular acceleration alpha. It's just that instead of the center of mass, we use the ICOR to write down the torque equation. Because if you use the ICOR, normal friction mg passes through ICOR. So you don't have to write down their torques. So what is force F? It is 49 Newton. Its distance from the ICOR is 2r. So torque will be 49 times 2 times the radius, which is 2r. This is the torque of 49. This will be equal to I alpha. So the moment of inertia about the center of the solid sphere is 2 by 5 mr square, right, solid sphere. So we have to add another mr square to it using parallel axis theorem. So moment of inertia about ICOR is 2 by 5 plus 1, which is 7 by 5 mr square. Okay, so equals I, which is 7 by 5 mr square times alpha. Okay, and ACM is simply going to be r alpha. So we cancel out 1 r, 1 not m will be there. So from here we get r alpha. R alpha will be 49 into 2 into 5 divided by 7m. Okay, and mass is probably given 20 kg. So you can substitute it. The answer will be 3.5 meters per second square. Okay, next question. Circular ring and solid sphere have same radius. It rolls down an inclined plane from rest without slipping. What is the ratio of their velocity when they reach the bottom? Okay, so inclined plane, they start from rest, and the two different bodies are a circular ring and a solid sphere. Okay, so the body starts from the top, reaches the bottom. We have to compare their velocities. Okay, so for comparing velocities, we'll use energy conservation between the top and the bottom, right? So the two bodies, when they reach the bottom, the decrease in potential energy is the same because they fall by the same distance h, right? So which means the decrease in potential energy mgh equals the increase in total kinetic energy delta k. So we have to write the kinetic energy of the body when it is at the bottom. Okay, now most of you guys remember this formula. If the center has a velocity v and of course the body is rolling, then the kinetic energy formula is half mv square 1 plus k square by r square. Okay, where this k is the radius of gyration. So for example, if we are talking about circular ring and solid sphere, the moment of inertia of circular ring is mr square. The moment of inertia of the solid sphere is 2 by 5 mr square. K square is basically this number, 2 by 5. Okay, and here it will be 1. So all you have to do is substitute it there and see in which k ratio of their velocities. So you just have to find v1 by v2. So in the first case, you can say half m v1 square plus 1 plus, instead of k square you will put 1 r square, instead of k square you will put r square for the ring case, and you will get velocity of the ring. And for the solid sphere, instead of k square you will put 2 by 5 r square, and you will get the answer for solid sphere. And now you can compare it. Okay, and once you compare it, the answer will be 4 in this case. The x value is 4. So yeah, using energy conservation, find the velocity at the bottom and then compare it. Next question. Two wires are made of the same material having length ratio and diameter ratio this. If both the wires are stretched using the same force, what would be the ratio of their respective elongations? So this is standard formula, Young's modulus equals stress divided by strain. Okay, now diameter ratio is given. So what you have to find is like delta L1 by delta L2. So length ratio is known to us, so you can find L1 by L2. Diameter ratio is known to us, so you can find A2 by A1. Force is the same, so in both F1 and F2 you will both substitute as F itself, and that is basically it. It's the same material, so same Young's modulus, so you can find delta L1 by delta L2. Okay, so yeah, this question is I'm skipping it. The answer will be 1:12. Okay, once you solve it. Cylindrical rod, radius, length is 1 meter, radius is 4 meters, so it's a thin rod. It is subjected to a shear force of 10 to the power 5 Newton at the top. Okay, shear force just means it's parallel to the cross-sectional area. So let's say this is the so this is, let's say, the cylinder. The shear force is applied here, so it means like if this is, let's say, at the top, if this is the cross-sectional area, the force is applied parallel to the cross-sectional area. Okay, that's the shearing force. So in this case the force will look like something like this. Now because of this shear force, this rod will bend by a tiny angle, right, theta. This theta is also called the shear strain. Considering infinitesimal small displacement in the upper edge, which means this angle theta is very small, infinitesimally small, the angular displacement theta of the rod axis from its original position. So you just have to find out this theta. That is the question. Okay, so first thing is, if this is the cross section at the top of the cylinder, the radius of the cylinder is given, it's 4 centimeters. The shearing force is also provided, which is the force applied parallel to the area. If I have the shearing force and the area, the shear stress, okay, the shear stress is going to be F divided by this area, which is pi into 4 centimeter square. Convert it into SI units. Now once you have the shear stress, using the shear moduli, you can relate the stress with the strain, which is shear stress, which is F divided by A, divided by the shear strain. Now shear strain is simply this angle theta. Okay, so if you guys have read NCRT, shear strain is simply this angle theta, and this angle theta is what we have to solve for. Okay, G is given, F is given, A is given, so you can just substitute it. Okay, so this is also a substitution problem. It's just that the formula is important, and the answer will be this option. Okay, once you solve it. Next question. Excess pressure inside a soap bubble. This is also a important formula, that's why I took it. So if I have a soap bubble, okay, remember the fact I told you guys earlier, it has two surfaces. So it is something important to note. If the outside pressure is P naught, then inside a soap bubble the excess pressure, which is the pressure on top of this P naught, is equal to 4 times the surface tension divided by R. Okay, that is the only thing you need to know about the soap bubble. And the excess pressure is basically this minus this. So delta P, the excess pressure is 4T divided by R. Okay, now two soap bubbles are given, and one soap bubble A has half the excess pressure compared to the other soap bubble B. Now if the A has half the excess pressure, it means its radius is double. So radius of A is double the radius of B. So you can just compare it. And now once you know the radius ratio, you can find the volume ratio, right? Volume of A divided by volume of B. So that will be 8, I guess. Yeah. Okay. Yeah, these are all JEE mains questions itself. Okay. Next. Solid steel ball, it acquired a velocity of terminal velocity while falling under gravity through an oil. So this is the typical viscosity once we study it. The formula that we discussed, the terminal velocity topic. So once the ball, the spherical ball attains terminal velocity, we do derivation for this terminal velocity. This has a quite large formula. It is 2 by 9 r square g times density of the object minus density of the liquid divided by the viscosity, coefficient of viscosity. This formula is what this question is based. If you know the formula, it's just plug and play. You have everything, you just have to solve for eta. Okay, so you can just remember the formula. The answer after solving will come out to be 1.99. Okay. So yeah, two blocks are placed on a frictionless table. Massless spring with spring constant K is attached with the lower block. If it is slightly displaced and released, okay, there are a few options in the next page, but situation is something like this: spring attached to a two block system. Between these two blocks, there is friction of mu. Okay. Now the first question is what is the time period of oscillations of the two blocks? Okay, so something else is given to us, and that is these two blocks are together. Okay, they move together. So if m is being displaced left and right, small m is attached to capital M itself. Okay, the friction is such that that motion is supported. That is, they both move together. If they both move together, then we can treat them as a single mass itself of capital M plus small m, and that capital M plus small m is attached to this spring. And this simple spring mass problem, we know the time period, it is 2 pi square root total mass divided by K. Okay, but you can only apply this if they move together. Okay, in some case, if the friction is not sufficient, small m and capital M won't move together. So the first option is correct. In the second option, the acceleration of the block is asked. Okay, where x is the displacement from the mean position. This is a SHM result. So if this is the mean position, okay, and if the blocks are displaced by a distance of x from the mean position, then you must be knowing the formula for acceleration at a distance x. Okay, at a distance x from the mean position, the acceleration has a direct formula. It is omega square x. Okay, so it is directly proportional to the distance from the mean position. Now what is omega? Omega is square root m by k. No, not k by m, square root m by, in this case it will be m plus m because both of them are moving together. So if they are at a distance x, omega square will be k divided by capital M plus small m multiplied with x. This will be the acceleration of the two block system if it is at a distance of x from the mean position. Okay, so that is what is given here. So the magnitude of acceleration, this is correct. Okay, next is what is the magnitude of frictional force on the upper block. Now in this question, both these blocks move together. Okay, so at a distance x, I guess is what they asked. What is the frictional force? Yeah, they want in terms of x when it is at a distance x from the mean position. So if the system is at a distance x, right, let's draw the FBD in that situation. This is capital M, this is small m, and it is at a distance x. So we discussed that its system's acceleration is omega square x to the left, right, which is this formula kx divided by capital M plus small m. Now if we isolate the small m mass, which force is providing this acceleration? It will be the frictional force itself, because there is no other force along the x direction which can provide small m the acceleration. So that frictional force will be equal to mass times this acceleration. Okay, so friction F on the small block will be mass m times this value, which will be mkx divided by capital M plus small m. This will be the frictional force acting on the block. Acceleration will be same for both, yes. So this will be the, I guess, no, this won't be the answer because there is a mu here. There won't be a mu in the term. So third option will be wrong. Maximum amplitude of the upper block if it does not slip is. Okay, so if it does not slip, if the blocks do not slip on top of each other, what is the maximum amplitude of this SHM? So first of all, let's try to take a feel for this. So firstly, with x increasing, which is the displacement from mean position, this acceleration will increase. And if this acceleration increases, we need more friction, right? But friction can only take a certain value until a certain value, which is what we call the limiting friction. And in this case, what is the limiting friction? We just have to find this normal reaction. This normal reaction will be equal to small mg, which means limiting friction will be mu times small mg. So friction cannot be larger than this value. Okay, so that limiting friction will decide what is the maximum value of the amplitude. Okay, so this mu mg, max friction force, we'll set it equal to m into maximum acceleration. Acceleration once again is just omega square x. If you do omega square, it is k divided by capital M plus small m. Okay, and instead of x we will put amplitude, right? This is the maximum amplitude possible, and this will be equal to, small m cancels out, mu g times capital M plus small m divided by k. Okay, so I hope that is clear. So mu times capital M plus small m divided by k into g. This is also the maximum amplitude of the upper block, mu capital M plus small m into g into k. It will be divided by k, right? It will be divided by k, but I guess that is a typing error. Yeah, that is a typing error. So here actually k was in the denominator. So this option will also be correct, D option. So far A, B and D is correct. Now in the fourth case, maximum frictional force can be, no, max friction was mu mg. This is always the limiting friction, right? So the answer will be A, B, D, which is first option. Okay, so that was this question. So next question is, equation of wave is given. What is the minimum distance between 2 points having the same oscillating speed? Okay, so this is just a simple traveling wave. Okay, you don't have to correctly draw it, but the minimum distance between 2 points having the same speed. Okay, so just take any 2 points. So here we have 0 speed, right? Here also we'll have 0 speed. So what is the minimum distance between these 2 points? Crest to crest or trough to trough distance is lambda, right? So this distance will just be half the wavelength. Okay, so the answer is just half the wavelength. Wavelength, you can find it out using the k value. K is 20 pi. So 20 pi equals 2 pi by lambda. So this becomes, I guess that is in meters, SI units, yeah. So lambda will be 1 by 10, 0.1, 10 centimeters. So lambda by 2 will be 5. Okay. All right, 5. Experiment, closed organ pipe is given. It is filled with water 1/5 of its volume. What will happen to the fundamental frequency? Closed organ pipe. Okay, so so yeah, of course this end is open, so I'm not drawing it. So in the fully like in the case with no water, this is how the standing wave pattern will look like. Okay, this is lambda by 4, and lambda by 4 is equal to the length of the container, right? When we fill it with water, what will happen is, let's say we fill water 1/5 of its volume, right? So 1/5 of its volume got filled. So this height will be L by 5 and this height will be 4L by 5. New standing wave pattern will be something like this. Okay, so this is once again lambda by 4. Antinode to node distance is lambda by 4. Okay, so main difference is in the length of the two organ pipes. So in the first case we will say L equals lambda by 4, and in the second case we will write L equals L by 4L by 5 equals lambda by 4. Okay, so lambda in the second case becomes 16L by 5 and lambda in the first case becomes 4L. That is the only difference. Now the fundamental note, fundamental frequency will be V, there's a wave speed divided by lambda, and you can just substitute the lambda in both cases and compare the answer. Okay, so okay, and after comparing and finding the percentage change, the answer will be 1. Okay. All right. Two cylindrical rods A and B are joined in a straight line. Ratio of lengths, radii and thermal conductivities of these rods are given. Free ends of the rod A and B are maintained at 400 and 200 Kelvin. Temperature of the interfaces. So you have two conducting rods, different radii, okay, something like this. LA, RA and KA, LA, RA, KA, and this is LB, RB, KB. So the first interface, one of the interface is maintained at 400 Kelvin. The other interface is maintained at 200 Kelvin. We have to find the temperature at this interface. Okay, let's call it T. Okay, so this we can convert it into the Ohm's law problem. Okay, so this conducting rod, its thermal resistance will be LA upon Ka times the area of cross section. This is the thermal resistance for the first resistance, and similarly you can find the thermal resistance for the second conductor, and now you can just compare it to the Ohm's law problem. This is RA and this is RB, and you can like replace the temperatures with voltages, right? So at this node you can treat it like 400 volts, over here you can treat it like 200, and you have to find the voltage at the junction. All right, okay. Now it's a Ohm's law problem. The current is the same through both resistors. So current in the first one is 400 minus T divided by RA, and the current in the second one is T minus 200 divided by RB. Okay, in the heat transfer terms, this is the heat current, but you can compare it with Ohm's law or circuit problems. After solving this, RA and RB are known to us. You can easily find the thermal resistance ratios, because thermal resistance is L divided by K times the cross sectional area. So you can simply take the ratio, everything is given, and you can solve for T. Answer will be 360 once you solve it. Okay, next question. thermodynamics, what is true for each of these processes, we have to match the list. So isobaric is constant pressure, so right, so what is delta Q basically? So delta Q is going to be delta U plus P delta V, right? So this A matches with 4. Isochoric is constant volume. In constant volume process, the work term will go to 0. So constant volume delta U will be delta Q. Okay, there won't be any work done in isochoric. Adiabatic, the heat transfer is 0, so it will match with this. And isothermal one, the internal energy will remain constant, so delta U would be 0. Okay. Now moving on, it's a simple match the list. There are two vessels with an ideal gas where volume of one is double the volume of other. Okay. So we have two vessels like this, vessel 1 and vessel 2. Everything is given, large vessel has gas at 8 kilopascal, 1000 Kelvin. So we know the volume ratio, right? If this is V, this is 2V. And also pressure and temperature for both of them are given, right? So the pressure, let's say P2, temperature T2, here pressure P1, temperature T1, they are known to us. If the vessels are connected to each other by a thin tube, okay, so we now connect these two vessels with a thin tube. Thin tube is mentioned because we don't want to consider the tube's volume, okay? We'll neglect the tube's volume with respect to V1 and V2. Now, the gas is allowed to flow and the temperature of both vessels is maintained at 600 Kelvin, okay? Then the question is, at steady state, the pressure in the vessels will be. What will be the pressure in the vessels? So first thing is, gas from this vessel might, transfer, they will mix with each other. But one thing is for sure, finally, their pressures would be identical. So let's say the final pressure is some PF. And the volume of the total gas will now become, so the final temperature is also given, it is 600 Kelvin. So the main idea here is that, let's say number of moles in the first vessel is N1 of the gas, number of moles in the second vessel is, let's say, N2. So finally when both gases mix, let's say the number of moles is N. Moles should be conserved, N1 plus N2 equals N. Okay. So now number of moles we can write it as PV divided by RT. So P1V divided by RT, so T1. For the number of moles in the first, it will be RT1. In the second vessel, it will be P2 times 2V divided by RT2. Finally, when both of the gases mix, the final pressure is what we have to find. State the pressure in the vessel. So finally, they will have a common pressure. Let's call it PF. Final volume is the total volume of these two containers, which is 3V divided by R times final temperature is given, it's 600 Kelvin. Okay, so now basically the only variable is PF. You can solve for it. All right, and once you solve it, the answer will be 6. Okay, moving on. It's mole conservation. That is the only concept here. All right. Characteristics of an adiabatic process in a monoatomic gas. So that is important. Internal energy is constant. So if this is of course not true. Internal energy is constant is only true for the temperature being constant. So A is wrong. Work done in the process is equal to the change in kinetic internal energy. But the issue with this is this could be true if magnitude was also given. That magnitude of work done is equal to magnitude of change in kinetic energy, internal energy. The product of temperature and volume is a constant. So for this we have to write down the equation of the adiabatic process. So you guys know PV raised to power gamma is a constant, but we can also write TV to the power gamma minus 1 is a constant. Okay, we can also write it like that by eliminating the pressure term. Now this is a monoatomic gas, meaning gamma value is 5 by 3, right? So if you do 5 by 3 minus 1, it will be 2 by 3. So TV to the power 2 by 3 is constant and not temperature into volume. So C is wrong. It's wrong because it's a monoatomic gas. The product of pressure and volume is a constant. This is also not true. The product of PV raised to power gamma is constant. The work done to change the temperature from T1 to T2 is proportional to T2 minus T1. So the work done in an adiabatic process, the formula is NR delta T upon 1 minus gamma. Okay, NR delta T upon 1 minus gamma. The work done to change the temperature from T1 to T2 is proportional to T2 minus T1. So for adiabatic process, we can write Q equals delta U plus work done, right? So work done is equal to negative delta U. Okay, so now delta U is NCV T2 minus T1. So this will become T1 minus T2 in the work done. So I guess this is some error either in the question or the printing. This should be T1 minus T2. Okay, because work done is negative delta U, which will be minus NCV T2 minus T1, which will make it NCV T1 minus T2. So work done is going to be proportional to T1 minus T2. Okay, but I guess the answer will be B and E in this case. But yeah, just keep it in mind. I guess it's a printing error. Okay. Gas is kept in a container having walls that are thermally non-conducting. So thermally non-conducting means heat transfer will be 0, Q equals 0. Initially the gas has a volume of 800 centimeter cube. Temperature is also given. Yeah, well, the first thing is the Q becoming equal to 0. There is no heat transfer to and from the container. So what does that mean? Process is adiabatic. Okay, so which means we can use the adiabatic process equation, and we have to relate volume and temperature. Okay, so TV raised to, we just discussed, TV raised to power gamma minus 1 is a constant. So now it's just you put V1 T1 here, V2 is given, you just have to find T2. Okay, that is this question. Answer will be fourth option, 300 Kelvin. Okay, you guys can confirm it after solving later. Gamma is also given. So cyclic process is given, graph is given. We have to find the work done by the gas in the entire cycle. So here in these questions, the work done is of course just the area under this cyclic process, which is the area of this circle. But the only thing you need to remember is the unit conversion. So find the area of the circle using pi r square. Okay, I mean you can use this radius. This will be of course 100 units, or this radius, which is also 100 units. So you can substitute r equals 100 here and find pi r square. But the units will be kilopascals centimeter cube. Okay, kilopascals centimeter cube. So make sure you convert this into SI units because you want the answer in joules. So kilopascals you will multiply it with 10 cube, centimeter cube you will multiply it with 10 to the power 6 to make it meter cube. So after that the answer will be correct. Okay, so answer is going to be 314. Yeah, somebody wrote it. Answer will be 314 once you solve it. Okay. Ideal gas exists in a state with pressure P0, volume V0. It is isothermally expanded, isothermal process, 4 times its initial volume. Then it is okay, so this is a complicated process, isobarically compressed original volume. Then it is, so this is a 3-step process. So whenever a multi-step process is given like this, amount of heat exchanged, it's better to draw the PV graph, okay. So because with the PV graph it's easy to see the work done. Okay, so firstly the ideal gas exists in a state with pressure P0, volume V0. So if I draw the PV curve, let's say it is somewhere over here, P0 V0. It is isobarically compressed to its original, it's expanded to 4 times of its initial volume isothermally. So isothermal processes are like a rectangular hyperbola. So its PV equal to constant, right? So the graph will look something like this. And this point is given to be 4 times the initial volume. So the volume coordinate will be 4 V0. And over here, the volume is V0. Isothermal expansion to 4 V0, okay. Then it is isobaric compression to the original volume. Isobaric is constant pressure, horizontal line basically, right? So isobaric compression would be like this, it moves to its original volume. So this is the second process, okay. First process, isothermal expansion, isobaric compression. Then it is heated isochorically to bring it to its initial state. Isochoric means constant volume or vertical line. So vertical line, something like this. This is the isochoric process. First process, second process and third process. So it's a cyclic process itself. This is the P0 V0 state. This is 4 V0, okay. But the temperature will be same. If I say the temperature here is T0, because this is an isothermal process, the temperature here will be T0, okay. And over here the pressure remains the same because it's isobaric process, and over here the volume is V0. Okay, so what are we trying to find? We are trying to find the heat exchanged in this cyclic process, okay. So we'll just use the first law expression. In the cyclic process, right, I can write Q equals delta U plus work done. Now because this is a cyclic process, we start from the same point and come back to the same point. So delta U will be 0 because the internal energy is a state function. So if you do delta U, it will be U1 minus U1 itself, right? So delta U will be 0. So which means all I have to do is find the work in these 3 processes. First process is a isothermal expansion. So the work is nRT ln V2 by V1. Number of moles, okay, we don't need the number of moles because we want the answer in P0 V0, right? So the work is nRT naught ln V2 by V1, which is 4, right? This is the isothermal work, but nRT naught using the ideal gas equation, I can write it as P0 V0, right? So this is the isothermal work because it's an expansion process, work is positive. Now we have a isobaric compression. So in the isobaric process, I don't know what the pressure here is, but we can find it. So in the isobaric process, the work done will be P delta V simply, okay. Now the pressure here we can compare using ideal gas equation. In this process, the temperature is constant. So if temperature is constant, it also means PV equals constant. So if the volume here is 4 times this point, pressure here will be 1/4 of this point. So the pressure here will be P0 divided by 4. Okay, so the isobaric work in this process, first thing is the work will be negative because it's a compression process, right? Compression processes have negative work by the gas. So it will be P0 by 4 times delta V. Delta V is 3 V0. So minus P0 by 4 times 3 V0. This will be the answer because isochoric work is 0. Okay. All right. You can check the options. P naught, V naught, ln4. ln4 is the same as 2 ln2. Minus 3 by 4, I guess it's first option, right? Okay. Next. Helium argon are put in the flask at same room temperature, 300 Kelvin. The ratio of their average kinetic energies. Ratio of their average kinetic energies per molecule. This is also important, of helium and argon. So helium and argon are monoatomic gases. So the average kinetic energy, we can write it as F by 2 nkt. So it will be 3 by 2 nkt. But because they are asking per molecule, we will divide it with the number of molecules, which means it is 3 by 2 kt. So it just depends on the temperature. Okay, and because they are in the same room temperature, it will be 1:1. Okay, there will be no difference. All right. Gamma A is a specific heat ratio of monoatomic gases having 3 translational degrees of freedom. Monoatomic gases only have translational degrees of freedom. That's why the degrees of freedom is 3. Gamma B is a specific heat ratio of polyatomic gas. Now this gas has 3 translational, 3 rotational and 1 vibrational mode. Okay, so if I have to calculate its degrees of freedom, it will be the 3 translational plus the 3 rotational plus 2 times the number of vibrational modes. Okay, and the number of vibrational modes is 1. This is something we discussed while covering degrees of freedom. The theory part is a bit complicated at 12th or 11th level. But yeah, so but whenever the number of vibrational modes are given, the degrees of freedom part will include 2 times the number of vibrational modes. 6 plus 2 will be 8. Okay, so now it's just a formula basis, a formula problem. So gamma is 1 plus 2 by F. Gamma of the monoatomic gas is just 5 by 3, right? Divided by, so if you put 8 here, it's 1 plus 1 by 4, so just 5 by 4, right? So this will be 4 by 3, 4 by 3. 4 by 3, if I have to write it like this, it will be 1 plus 1 by 3. So the answer for N is 3. Okay, so answer for N is 3. Next, metal spheres radius r and 3r have the same surface charge density sigma. So they are brought in contact and then separated. The surface charge density on the smaller and bigger sphere becomes sigma 1 and sigma 2. So in the question, everything is written in sigma 1 and sigma 2. So if I have a sphere and the charge is q, what is the potential at the surface? We will try to convert it into sigma. So the potential, we know it is kq divided by the radius. This I can also write it as 1 by 4 pi epsilon naught. Q I can write it as sigma 4 pi radius squared divided by the radius. So this will be sigma r divided by epsilon naught. So this formula can also be written like this. Okay, reason is, in the question everything is discussed in terms of the sigma, surface charge density. So now once the two spheres are touched, the potentials become equal. V1 becomes equal to V2, which means sigma 1 R1 becomes equal to sigma 2 R2. Okay, so R1 and R2 ratio is known. What we need is sigma 1 by sigma 2, which will be R2 by R1, which is 3. So option will be the fourth one. Okay. So yeah, this is this question. Next one, Electrostatic potential at the surface of my uniformly charged spherical shell. Radius of the shell is 10 centimeters. At the surface, the potential is given 120 volts. Okay, so 5 centimeter, this point is inside the shell. At the center of the shell, this is also inside the shell, and we need to talk about at 15 centimeters from the center of the shell. We need to find the volumes. So firstly, inside a uniformly charged shell, right? Inside everywhere the potential is the same. So at the center also it will be 120 volt, and also at R equal to 5. 5 is inside the shell. Here also the potential will be 120 volt. In fact, the only option matching is the first option. And at 15 centimeters, you can use ratio and proportions. So potential is proportional to Q by R, right? So V at 15 centimeters is what we have to find. So we'll call it as V. V at the surface, which is at surface is at 10 centimeters, right? So at 10 centimeters, I know the potential is 120 volt. So now I can do V2 by V1 is equal to R1 by R2. Okay, and then I can get V. But yeah, the only option in which R equal to 0 and R equal to 5 are having 120 volt is A option. So that will be the answer. Small bob, mass is 100 milligrams, charge is 10 microcoulomb. So it is attached to an insulating stand. So of course the electric field due to the infinite sheet will push the charge away. The angle is given. The charge density of the sheet is being asked. So sigma is what we have to find. Okay, so this is a F equal to ma problem mainly. So we'll have the electric force to the right, which is QE. We'll have the weight acting downwards. Mg. And this is the tension force. It will be along this wire. So of course the resultant, now you can either balance x direction force and y direction force, or you can just use the fact that tan theta equals 45 degree. The resultant of mg and qe should be along this 45 degree line, and this resultant balances out this tension. That's how equilibrium is possible, right? Which means this angle is 45, which means mg and qe are equal. Tan theta equals 1, so mg equals qe. So now m is known, g is known, q is known, you can solve for E. Electric field due to an infinite sheet at that point will be sigma by 2 epsilon naught. Epsilon naught is also given, so you can solve for sigma. Alright, next question. Two infinitely large parallel plate conducting plates is given, sigma and minus 2 sigma. Keep in mind this is conducting, okay? So the charges can rearrange. The plates are uniformly charged, okay? The force experienced by the plus q charge placed at the midpoint. Okay, so the system is plus sigma and minus 2 sigma. This is how the system is. This is one infinite charge sheet. This is the other one. This guy's total charge is plus sigma. This guy's total charge is minus 2 sigma. Okay, so now because this is a conducting plate, the charges we will redistribute. Okay, this is something we cover in capacitors. The logic here is that the average of these two, which is sigma minus 2 sigma divided by 2, whatever this is the charge that appears in the outer surface, either of the outer surface. So this will be minus sigma by 2. Okay, so this minus sigma by 2 appears here, and another minus sigma by 2 appears here. Okay, now what will be the charge on the inner surface? We can find it by subtracting it from the total. So here it will be 3 sigma by 2, and here it will be minus 3 sigma by 2. So this is how the charge distribution will be due to the conducting plates. Okay, because these are conductors, their charges will rearrange. Now we have some q charge placed at the center. This distance is d by 2 and this is also d by 2. We need to find the total force. Okay. Now because of this minus sigma by 2, the force will be to the left. Because of this it will be to the right. So they will have 0 contribution. Because of this 3 sigma by 2, there will be an electric field here, right, and that will be sigma by 2 epsilon naught, right, but instead of sigma it will be 3 sigma by 2. And because of this minus 3 sigma by 2 also there will be the same electric field to the right. So the total will be 2 times 3 sigma by 2, which is the sigma of this surface, sigma by 2 epsilon naught. This will be the total field. So the answer is 3 sigma divided by 2 epsilon naught. Okay, so option B will be the answer. Electric field multiplied with the charge will give us the force. Okay. Explain this again. Actually, if you know the charge redistribution in this case, so actually what happens is if you have two conducting plates like this, the charges, like if this is sigma, it's not going to exert a sigma by 2 epsilon naught to the right, and this minus sigma won't exert a minus 2 sigma by 2 epsilon naught to the right. And the reason is because these are conducting plates, okay, so their charges redistribute, and the logic to find the redistribution is first you find the average charge of sigma and minus 2 sigma, and averages you add them and divide by 2. This charge is what comes at the end plates. So here it will be minus sigma by 2 and here also it will be minus sigma by 2. Okay, and now the charge inside okay, so I hope that is clear. Previous channel name, yeah, that is my channel. So yeah, and once you find the charge distribution, that will be done. Okay. Next question is this one. Charged spherical body of charge density rho. So we have three things: a sigma infinite plate, another sigma infinite plate, a charged sphere whose charge density is rho. We have to find the electric field relations at A, B, C and D points. Okay. And A, B, C, D. So these points we have to compare the electric fields. Okay, we have to compare at A and B first. In the first parts, we have to compare A and B. So at A and B, so now due to these two infinite plates, inside everywhere the field is 0, right? So take any point, because of this sigma, it will be sigma by 2 epsilon naught to the right. Because of that sigma, it will be sigma by 2 epsilon naught to the right, left, and they cancel out. So the infinite sheets are not useful at inside points. So electric field at B and electric field at A will be mainly only due to the sphere. Now due to the sphere, electric field at A will be greater, right? So EA is clearly greater than EB. So first option is wrong. Okay. In this option also EA is greater than EB. And last option is also wrong. So now we need to compare EC and ED. C is a point over here. D is a point over there. Now once again, due to the infinite sheets, the fields are similar, right? Because of this guy, the field will be sigma by epsilon naught to the left. And because of the two sheets, at D, the electric field will be to the right, sigma by epsilon naught. Now, due to the sphere, because D point is closer to the sphere, the electric field contribution due to the sphere will be greater here, right? Because D is closer to the sphere, which means electric field at D will be larger than electric field at C. So they are not equal. So option 3 will be correct. Okay. Yeah. Here they are saying C and D have the same field. So this will be wrong. So the only correct option is the third option. Okay. Metallic ring uniformly charged, AC and BD are two mutually perpendicular diameters. Electric field due to arc AB to O, at O, it should be at O, due to arc AB at O is E in magnitude. What will be the magnitude of electric field at O due to ABC? So due to this arc AB, so basically in electric fields due to circular arcs, we discussed an important idea, and that is the electric field due to, let's say, this quarter circle AB, it will be along the angular bisector. The direction will be along the angular bisector of this quarter circle AB. Okay, and this magnitude is given by E. Okay, in fact, we don't need any formulas here, we just need to use this fact that the electric field is along the angle bisector. Okay, so now the question is, what would be the magnitude of electric field at O due to arc ABC? Can we do it without the formulas? That's what I'm thinking. Okay, anyways, yeah, we can. So because if this quarter circle has an electric field E in this direction, now we need the electric field due to this semicircle, right? This semicircle we can break it down into quarter circle 1 plus quarter circle 2. Now this quarter circle similarly will have an electric field along the angle bisector, which we'll call it as, which we'll write it like this. This will also have the same magnitude because the first one was due to this quarter circle, and this quarter circle is also identical, exactly identical. Now because this is a angle bisector, this angle is 45, this angle is also 45, right? So these two angles are 45. If I have E and E at an angle 90 degree with each other, right? Two equal vectors are at an angle 90 degree with each other. What is the electric field? What is the resultant? The resultant will be root 2E, right? This should be root 2 times E, and this will be the answer. Okay. All right, moving on. Using a battery, 100 picofarad capacitor is charged to 60 volt. Battery is then removed. Okay, so initially the one capacitor is charged to 60 volt. After that, a second uncharged capacitor is connected to the first capacitor in parallel. The final voltage is given. Its capacitances. So we have capacitor 1 like this, capacitor 2 like this, and they're connected. But the thing is, the first capacitor, who's 100 picofarad, this was already charged to 60 volt, right? So if you multiply it with 60, you will get the initial charge. So let's say this switch was opened up initially. So this had some initial charge Qi, okay, which we can get by multiplying C into V. So what will happen is, once we connect it, because they're connected in parallel, finally their voltage will be the same, right? So what we'll do is, we'll do charge conservation. Okay. So initial charge before closing the switch was 100 into 60. I'm going to call it, so let's say this is C1 capacitor, and this I'm going to call it as V1. So initial charge will be C1 V1. Okay, this was the charge in the first capacitor. Now we close this switch. Once we close the switch, final voltage will be the same. So finally the charge on the first capacitor plate will be C1V, and on the second capacitor plate it will be C2V. Okay. Now the thing is, we don't know C2, we know V, we know C1, we know C1 and V1. You can solve for C2. Okay, that is a question. We have to find C2, and the answer will be 200 once you solve it. So main idea was charge conservation. Initial charge is C1 V1, 100 into 60. It is equal to C1 into V plus C2 into V, because finally both of them will have the same voltage. So charge in the first capacitor is C1V, Charge in the second capacitor is C2V. Okay, yeah, it will be the second option. So this is a capacitor problem. We can just quickly discuss it. So we have, in the first case, we have two capacitors, two dielectric plates attached in series like this. So just find capacitance of this half part and this part C2, C1 and C2, and they are arranged in series. So the total capacitance will be C1 C2 by C1 plus C2. Its only thing is you have to know how to write C1 properly. It will be epsilon not A by D, but because this is a dielectric plate, you have to include its epsilon as well. Epsilon not epsilon 2 area of this plate is, let's say, A divided by D by 2. Similarly for this, it will be epsilon not epsilon 1 A divided by D by 2. For this, the only difference is the area is A by 2, but D is the same. Okay, and here you would treat it as parallel. Parallel ones, the formula is C1 plus C2. Alright, so we can skip this question. I'll give you the answer. The answer will be, oh, I don't know the answer in this case. Yeah, I don't know the answer, but yeah, let's move on. It's simple series parallel. This is also similar, like everything is given. This is a series combination. It's just it has values. So you can practice this question. Yeah, these kind of questions have high probability of coming. The capacitor dielectric one. So it's pretty important you practice these. For this question, I guess I have the answer. It will be 15. Okay, you guys can practice and check later. Current passing through, current function is given as time. Current as a function of time is given. Okay, so you want to find the charge that will flow through the wire. So current, we can write it as dq by dt, right? And now it's a problem of finding the charge. So you will integrate the current. Substitute the current as a function of time, integrate it from the initial time till the final time, and you will get the total charge flown. Okay, so I guess everybody knows this. So you have to integrate from 1 to 2, put the time current function. The answer will be 0.04. Okay, this is also just a calculation question. All right, and yeah, so this is a triangular pyramid as shown. So basically this, you can think of this point coming out of the page. So this is a pyramid, but when you look at it from the top, it will look like this, right? All the segments have the same length, but it's important, what they have mentioned is a wire of resistance R is bent into a pyramid. Okay, so each of these resistance is not R, but they will be like, how many sides are there? 1, 2, 3, 4, 5 and 6. So each resistance would be R by 6. All right, we started from R and we made 6 pieces. So each piece will have R by 6 radius. Okay, resistance between A and B is, we need to find the resistance between these 2 points. Okay, so we'll use symmetry here. So the main symmetry is, if you draw a perpendicular over here, as you can see, left and right has a symmetry to it, mirror symmetry. So you can either think of it like this point and this point. Any point that lies on this purple line will have the same potential, and if these 2 points have the same potential, it means current through this resistor will be 0. Okay, or you can also think of current symmetry. Current entering through this branch is the current going through this branch, and the current going through this branch is the current going through this branch. Either way, the current in the middle one is 0. Okay, so which means you can get rid of this. This is useless. Ignore that. So this is 2R. If I say individual resistance is some small r, this will be 2R because they are in series. This is also 2R because they are in series. This 2R and this 2R will be in parallel, so their equivalent resistance will be R. So finally we'll have an R like this, and an R like this. This R is equal to capital R by 6. So what is the equivalent resistance? It's simply small r by 2, which will be R by 12. Okay. So I guess we wanted the by 12, the 12 answer. So D option. Okay. All right. Another circuit problem, resistance 150.4, it is connected to series to this ammeter. Shunt resistance is connected to the ammeter, it's 10 ohms. Okay. The ammeter resistance is given as 240 ohm. Okay, so you can just consider another 240 ohm over here. Now the question is, what is the reading of the ammeter? Okay, we need to find the current passing through the ammeter. Basically we need to find this current. Okay, all right. So now, so the main logic is, firstly we find the R equivalent of these two parallel resistances. So that will be 240 into 10 divided by R1 plus R2, which is 250. All right, so now you just have to find this. How much will this be? I think it will be 9.6, I guess. Let's see. 240 divided by 25. Yeah, 9.6. So 9.6 is in series with 150.4. So total resistance is 160. Voltage is 20 volt. So this current I will be 20 V divided by the total resistance 160. Okay. Yeah, 1 divided by 0.125. Yeah, this will be 0.125. Let me check the answer. Yeah, so 0.125 amperes, right? So this will be 0.125 amperes. So I guess the answer, they want it in milliamperes. So this current of course will split over here. So let's say this is some I1, this is some I2. We need to find the I2 current. Okay, so we'll do current splitting there. This is 125 milliamperes, right? Now how do we do current splitting? Over here we need I2. So I2 is going to be the opposite resistance. I2 is going to be, firstly the total current is 125 times opposite resistance, which is 10, divided by sum of this, which is 250. Okay, so this will be I2. So the answer is 5. This will be the current through the ammeter branch. Okay, all right. Loop AB CDA carrying current I is placed in the plane, consists of two semicircular segments. Radius R1 and R2 are both given. Magnitude of the resultant magnetic field at the center. Okay, we need to find the magnetic field here. We already seen this formula once. Due to these two wires, it will be 0. So because they pass through O. Because of this, now due to the ring's magnetic field is inversely proportional to R. So smaller rings will contribute larger magnetic field. So this guy will contribute a greater field, and the direction you can use right hand rule. So it will be into the page. So at point O, due to this small wire, it will be X direction into the page. Due to the outer part, it will be out of the page. So outer one will contribute a dot field, but because the smaller one is larger in magnitude, it will be greater. So the net field is inside. You have to subtract it. Okay, so the answer will be mu naught I divided by 2R2, not 2, 4R2, minus mu naught I divided by 4r1. This will be the answer. Okay. Yeah. Physics Nation, that is correct. But because this is half the ring, you can just use half, right? Mu naught I by 2r into half. How many more questions? There are like 20 more. We can speed up if you guys want even more. Net will be into the page, yes. Okay. Yeah, if you guys want the answer, it will be 1. This value of k is 1. Okay. Particle charge 1.616 microgram. It is in a strong magnetic field of 6.28 Tesla. So charged particle in a magnetic field. It is fired perpendicular to the magnetic field. The time required for the particle to return to the original location for the first time. This is just a formula. I mean, this question I took to revise the formula. So if you perpendicularly project a particle in a magnetic field, firstly the radius formula should be remembered. The radius is mv divided by qb, right? Okay, so the radius formula is mv divided by qb, and the time period of this circular orbit, this formula is 2 pi m divided by qb, right? These two formulas should be remembered. T by 2? No, it's actually t only. They're asking the time required for the particle to return to original location, so full time period. Okay. All right. Yeah, we'll speed up. Okay. This is a current carrying loop. We have a square loop. Okay. Resistance of ABC. This part has R resistance. This part has 2R resistance. Okay. Now, if both the currents were same, then the answer would be 0. Right. We saw it earlier. Right. Then the answer would be 0. Because this contributes an inward current, this contributes an outward current. So if both currents were the same, then the magnetic field would be 0. But because the resistances are different, the current would be different. So this path is R resistance, this path is 2R resistance. So resistance ratio is 1:2, so current ratio will be 2:1. So if I divide I in 2:1 ratio, this will be 2I by 3, this will be I by 3. Okay, I hope that is clear. Smaller resistance path will have greater current. Now the thing is, you guys have to apply the formula, right? So this formula we already saw, in which we had the 45-degree angle. So I am not recovering it again, but I guess you can easily write it. Okay, this 45-degree for this wire, it is inward. For this wire also, it will be inward. For these two wires, it will be outward. So the direction is important. So you guys can try this out later. I'll write down the answer. The answer would be option 3. Okay. You guys can try it out later. So this question, we have two different regions, B1 and B2 magnetic field. Once again, a charged particle motion in a magnetic field problem. So the thing is, it's given the interface at an instant moves into the region 2 with velocity v. So it moves downwards with velocity v and returns to the interface. So they are saying the motion is something like this. Okay, it returns to the region 1 and then finally reaches the interface. Okay, it moves into region 2 with velocity v and returns to the interface. It continues to move in region 1, finally reaches the interface. What is the displacement of the particle during this motion? This is important. The magnetic field in the second region is bigger in magnitude. Okay, so remember the radius formula once again. It is mv divided by qb. Larger the magnetic field, the smaller the radius of the particle. B2 is larger, which means in that region the radius will be smaller. First, the particle goes into region 2, right? So it will initially move in the smaller radius region, then it will go into the larger radius region, and here the radius will be larger. So the motion will be something like this. Is that clear? Because in the second region, radius is smaller because the magnetic field is larger. So the smaller radius will complete over here, and in the first region, once it enters, we'll have a larger circular path. Okay. Now the question is, what is the displacement? of the particle. Displacement is just the difference between the initial and the final position. This was the initial position, this is the final position. This will be the displacement. Okay, so what exactly is the displacement? This is pretty easy. What is this? This is 2 times the radius in the first region, right? Semicircle, 2 times, let's call it R1. So this will be 2R1 and this will be 2R2, right? So the displacement D is nothing but 2 times of R1, 2 times radius of the bigger region minus 2 times the radius of the smaller region. R2 is less than R1. Yes, that is correct. Now you can just substitute the formula here, right? MV by QB. All right. Okay, so question is done. I'll give you the answer. Fourth option, once you solve it. Moving on. The current function is given, which looks like this, some time varying function. We have to find the RMS current. Okay. So RMS current, in the first session I discussed the method. The method is, first you find I square function, second is you find the average of I square, third is you take the square root of this thing. Okay, this is step 1, step 2, step 3. Okay, now firstly, if you square this current function, what all terms will be there? So if I square it, we'll have a square, which is 5 root 2 whole square. So 25 into 2, 50, right? And then we have b square, which is 100, some cos square term, right? The cos square inside we'll have this. And the third term will be having a cos function, right? This is what we'll get after we square it. Now, that was step 1. Step 2 is we need to average it. So this process is probably known to you guys. The average of I square is simply the integral of I square dt upon integral dt, and you have to do it for one time interval, 0 to capital T. What is this T? 2 pi by omega. Yeah, exactly. So the thing is, in this question we don't have to integrate because the functions are easy, I mean known to us. If you find the average of I square here, constants, if you observe, just if you take this 50 term, if you put I equals 50 over here, that you can just take it out of the integral and then you will have dt by dt. So this will be, average of 50 is simply 50. There is nothing to think about. And plus 100 cos squares average in one time interval. If you integrate from 0 to t, cos squares average is going to be half. Okay, you can try out this exercise. You just have to integrate cos square, use this formula 0 to t. What is t? It is 2 pi by 650 omega. You can try it out. The answer will be half, okay, in one time interval. And cos average, this will be 0. Okay, integration, if you do cos for one time interval, it will be 0. So the average of I square, this is actually just 100, right? So now if you just take the square root, you will get the IRMS, which would be 10 amperes. Okay, so I hope that is clear. So because cos square and cos average are easy to find, this is easy. Otherwise, if they give you some complicated function, you will have to use this formula. Alright, next problem. Electric bulb rating is given. Connected to an RMS voltage of 220 volt. The peak value is the, so if I have the current function as I naught sine omega t plus some phi, this I naught is the peak value. Okay, I naught by root 2 is the RMS value. So we have to find the peak value of the current. Okay, so if you remember the power formula, the average power formula, this was VRMS times IRMS, right? Power and average power and VRMS is given. That will be 100 divided by 220. So this is the RMS current, but we wanted the peak current. RMS current in this case is I naught divided by root 2. So all I have to write is I naught divided by root 2 here, and I can get I naught. Okay. So once you do the calculations, it will be 0.64, A option. Okay, you guys can check it. Radii of curvature for a thin convex lens. So the two radii of curvatures are given, 10 and 15. The focal length of the lens is 12 centimeters. Refractive index of the material is. This is just the lens maker's formula applied. So this surface has radii of curvature R1. This has R2. So if we apply the lens maker's formula, it will be 1 by the focal length equals refractive index of the material minus 1 into 1 by R1 minus 1 by R2. Just substitute R1 and R2 with sign and you will get the answer. Everything else is given. 12 R and R2 is given. You just have to solve for n, right? So the answer is 1.5 if you solve it. Okay. Ray of light suffers minimum deviation. So this is another class of formulas. Minimum deviation of a prism is also quite important. Angle of the prism is given, it is 60. This angle is 60. Okay, and refractive index of prism material is given. Angle of incidence is. This is the important part, minimum deviation. So in which case is the deviation minimum in the case of refraction in a prism? That is the main part. So let's say the situation is something like this. What exactly is deviation? Deviation is how much did the emergent ray deviate from the original ray. So if I extend this line and if I backtrace the emergent line, this is how much deviation happened. This is what we call the angle of deviation. Okay. Now this deviation angle becomes minimum in a very specific case. That happens when the angle of incidence equals angle of emergence. Okay. This is a concept that you should remember. And this delta's general formula is also important. It is I plus E minus the angle of the prism. Now because this is what happens in min deviation, we can write I plus E as 2I minus the angle of prism. Okay. This is the angle of minimum deviation, delta minimum. Now there is another formula which is the relation between mu and minimum deviation, which is mu equals sine of A plus minimum deviation divided by 2 upon sine of A by 2. Okay, this is another formula that you should remember. If you substitute everything into this equation, mu and A is given, you can find delta minimum. Okay, once you get delta minimum, you can substitute it into this formula. Angle of prism is known and you can find angle of incidence. Okay, so this is also testing you if you know this formula or not. Main thing is for minimum deviation, this is the condition, I will become equal to E, and yeah, that is it. Okay, and this formula is important, and that is also important, the 2I minus A formula. So once you solve it, the answer will come out to be 45. Okay, this answer will be 45. All right. So next problem, we have a slanted object placed on one side of a convex lens. Image is formed on the opposite side. This is also a formula based only. Angle based made by the image with the principal axis is. So first thing to notice is that this is a small object. Okay, so the x distance of this arrow is 1, y distance is 2. This is a small arrow. Okay, sometimes they give you a large arrow, like sometimes they give you a large arrow of like 10 centimeter, 15 centimeter length. In fact, I think in today's shift, this problem also came where the length of the arrow was like 15 centimeter. Now, if it's a large arrow, then you cannot use the magnification formula. We can only use that for a small formula, a small arrow. For a large arrow, you have to apply the lens equation twice. Okay, first you have to apply the length equation for this point. Consider the object distance u1, find v1. Then you have to apply object distance u2 for the arrowhead and find v2 if it's a large arrow. In this question it's a small arrow. Okay, so we can use the magnification logic. So firstly we will find out where is the base of the arrow. Object distance is 30. You can find using length formula. Okay, so 1 by v minus 1 by u equals 1 by f. With sign if you put, you can get where the base of the arrow is. Okay, answer minus 45. Yeah, I guess it's minus, let me check. Yeah, it is minus 45, yes. So the main idea here is the other arrow, when you find the image arrow, it will also be tilted like this at some angle. First you have to find v using the length equation. That will tell you where the base of the arrow is. Okay, that will tell you where the base of the arrow is. Now you need to use the transverse magnification formula, that is hi, height of the image divided by height of the object. This will be equal to v divided by u. Okay, everybody knows this formula. And here height of the object you will put as plus 2 centimeters. V and u you will solve, you will put with sign, and you will get height of the image. Okay, it will turn out to be negative. So the height of the image will be some negative answer. Okay, because u is negative, right? That is why. Now the thing is, for this along the optical axis also there is some dimension, right? Let's call this distance as some du. This is something that we call as the axial magnification or longitudinal magnification. This du, because of this, there will be a dv magnification or dv magnification along the axis, and that is given to us. There is a formula for that as well. That magnification is m square, which is equal to v by u the whole square. Okay, so basically the main concept is, if you keep, let's say, a tiny arrow along the optical axis, this has to be a small arrow in the axis of a convex lens. If the length of this arrow is, let's say, du, then the length of the image arrow dv, this dv divided by du is the magnification along the axis. That magnification is given to us by m square, which is v by u the whole square. So which is basically this magnification the whole square. Okay, and you already know du, it is 1 centimeter. So we will put du equals 1 centimeter. M we already know, we'll get dv. Another thing to observe is dv is always positive, which means if one is along the right, then here also it will be along the right itself. So ultimately, if you join these two, this is how the image arrow will look like. And if you want to find out this angle alpha, tan alpha will be height of the image hi divided by this dv. This will give you the answer. Alright, so yeah, these two formulas are important. Along the axis, that magnification is given by m square. Remember, it's only true for small objects. And perpendicular to the axis, you guys know the class 10th formula, v by u. Okay, answer will be minus 45. This minus is because the object is below the x-axis. Okay, all right. Next question is based on TIR. Transparent block has a refractive index of 1.25 surrounded by another medium of refractive index 1. Light ray is incident on the flat face of the block with incidence angle theta. What is the maximum value of this angle theta for which light suffers TIR? Okay, so we want the light to perform TIR, so the light ray goes parallel finally. We'll have to apply Snell's law twice, that's it. So sin theta equals 1.25 sine alpha, and this angle is actually 90 minus alpha, right? This is also the critical angle, because if light intercepts at critical angle, emergent ray is parallel to the cylinder's axis, or this angle is 90 degree. So sine theta c, we can easily find it is equal to, so sine theta c into 1.25 is equal to 1 into sine theta. So this will be 4 by 5, right? 1.25 is 5 by 4. If it goes to the other side, it is 4 by 5. So this angle is actually 90 minus theta c, right? So alpha is 90 minus theta c. So sine of 90 minus theta c will make it cos theta c. If sine theta c is 4 by 5, cos theta c is 3 by 5. 1.25 is 5 by 4. This will be 3 by 5. Answer is 3 by 4. Sine inverse of 3 by 4. C option. Yeah. C option. Yeah, Prachi, you are correct. Next question. This is based on apparent depth. Okay. Contains a liquid, refractive index 1.2 up to a height of 60, and we have another liquid 1.6 added to a height h above the liquid. If viewed from above, the apparent shift in the position of the bottom of the container is 40 centimeters. Okay, so these terms are important. So to revise that, I picked up this question. So in a container, if we have some fluid like this, and the fluid's refractive index is some n, and let's say we have some object placed at the bottom of the container, and the depth of the object from the fluid surface is some capital H, then the question is, when you view it from the normal direction, it will appear as if this object is lifted up by some distance, okay, and this distance is what we call as the apparent depth. Okay, this distance from the fluid surface is what we call as the apparent depth, and this turns out to be the distance h of this object from the surface divided by the refractive index. Okay, so this is the apparent depth, whereas the object shifted, the image shifted by this much. Okay, this is what we call as the apparent shift. So if you want the apparent shift, you will have to subtract h by n from h. So this will be h minus h by n. Okay, and this is the apparent shift. Okay, so it's important to keep this in mind. What is apparent shift and what is apparent depth? Okay, and now the thing is, what happens if we have two liquids? If we have two liquids, or let's say n liquids, there's a direct formula for this which we will discuss. Let's say this is H1 and the liquid refractive index is N1. This is H2, liquid refractive index is N2, and let's say we have liquids stacked on top of each other. In this case, the apparent depth is going to be H1 divided by N1 plus H2 divided by N2, and you keep on adding this however many liquid surfaces are there. Okay, so here in this particular question, we have the first liquid refractive index as 1.2 and height 60. So if I calculate the apparent depth, it will be 60 centimeters divided by 1.2 plus the second another liquid having refractive index is 1.6 is added to height h above the first liquid. So this liquid's thickness is h, so h divided by 1.6. Only two liquids are there. If you get the answer to this, what you get is apparent depth. Okay, but what is given is apparent shift. Okay, so that is the confusing part in this question. So this problem is like this: we have two fluids. This is 60, this is h. Okay, and they have given us the apparent shift, which is, if I keep the object here, what is this distance? That distance they have given as 40. Okay, this distance A I have given as 40, but the distance this formula gives us is the apparent depth, which is this distance. Okay, so you have to subtract this 40 from the total. So that will be h plus 60 minus 40, which is h plus 20. So what this is h plus 20. So I hope that is clear. So you need to understand the difference between shift and depth in this question. That is all. Now you can solve for h, and yeah, the answer will be 80. 80, yeah. The answer is 80. Okay, so that is clear. Next question. Two monochromatic light beams have intensities in the ratio 1:9. An interference pattern is obtained by these beams. The ratio of intensities of max to minimum is. Okay guys, solve this question. I'll be back in like 1.5 minutes. I'll be back now. Okay, so let's continue. So this formula is also probably most of you know it. The I max divided by I minimum formula. This is square root I1 plus square root I2 upon square root I1 minus square root I2, and this entire thing squared. Okay, so this formula is also known to you guys. Let's see, the answer is fourth option. Yes, fourth option. Okay guys, I'll you guys will get the PDF. All you have to do is join the WhatsApp link in the description over there. I share this PDF. Okay, and in the PDF, like on the bottom right, you will see the answers as well, the formulas as well. Okay. So monochromatic light beams, 4i and 9. This is also the same question. Okay, it's just written in a different way. Maximum will be how much? Like 2 plus 3 and the whole square of that. That will be a 24i, and the difference would be 3 minus 2. So 25 minus 1. I guess this will be 24. You guys can check it out. Okay. This question is different. Monochromatic light is incident on a metallic plate having work function phi. So photon incident on a metal plate. We have electrons emitted normally to the plate from a point A. Photoelectric effect. Max kinetic energy enters a constant magnetic field perpendicular to the initial velocity of the electron. Electron passes through a curve and hits back the plate at point B. What is the distance between point A and B? Okay, so magnitude of charge of an electron is E, mass is m, h is Planck's constant, c is velocity of light. Magnetic field exists everywhere. So basically, this is, let's say, the metal plate. Magnetic field exists everywhere above. Some magnetic field will take into the page. Electron is emitted perpendicularly, so of course it will move in a circular path, and after covering a semicircular path, it will come and hit back the plate. Now the question is, what is the distance between these 2 points? So that will be the 2r radius, right? Diameter of this circular path. So 2 mv by qb. So that distance is just 2 mv divided by qb. Okay, so now the game is how to relate v to the photoelectric idea. So for the photoelectric, so once the electron is emitted, it's given that its max kinetic energy, and max kinetic energy we know it is hc divided by lambda minus work function, right? So we'll convert this momentum to kinetic energy using the formula square root 2m kinetic energy divided by qb, and this will give us the answer. Kinetic energy will be hc by lambda minus I, 2 root 2 will be there. If you take the 2 out inside, yeah, it will be 8. Okay, Prachi, yes, that would be correct. Option 3 is correct. So yeah, that is this question. Bohr model of atoms, ratio of the 5th orbit radius of lithium and helium. Okay, so this is also formula based. For the hydrogen atom, the radius of the nth orbit is a0 n square by z. Hydrogen like atoms, right? Here a0 is the, some of you may know, it's 0.529 Armstrong, right? So this is the first orbit of the hydrogen atom, n equal to 1, z equal to 1. So here we have to just take the ratio. 5th orbit is fixed, so when you do R Li divided by R He, this will be Z helium upon Z lithium. Right? This is also formula based. So 2 by 3, I guess. 4th option. Yeah. All right. Hydrogen like atom ion, the energy difference between second excitation energy is just n equal to 3. Okay, we have ground, first excitation, second excitation. This is n equal to 3. Okay, what the difference between second excited state and the ground is 108.8 electron volt for hydrogen like ion, the atomic number of the ion is. So for the hydrogen atom, this is minus 13.6, this is minus 3.4, and I guess this is some minus 1.51 something. So if I take the difference, so basically the formula is 13.6 into 1 minus 1 by 9, right? This is what they, into z square. This is what they have given as 108.8. Okay, so you can solve for z square here. 4. Let's see. Yeah, 4 is the answer. 4th is the answer. Okay, this is just the energy delta E formula. Ratio of the largest wavelength of Lyman series to that of the Balmer series for a hydrogen atom. Okay, so Lyman series is basically all the transition lines that come to n equal to 1, ground state. Okay, and the thing you need to remember is delta E, which is the electrons like transition from n equal to n1 to n equal to n2. Whatever that delta E is, this releases a photon whose wavelength is lambda, and the relation is given by this formula, right? So the thing is, the smaller the wavelength, it means so basically the smaller the wavelength, the larger the energy difference. So they want the largest wavelength, denominator maximum means value is small. So we want the smallest energy difference or smallest delta E. So Lyman series are those lines that finally end up in like n equal to 1, like these. Okay, so now if you include 4 to 1, that is a high energy change. Similarly 3 to 1 is high energy change. Smallest energy change will be from n equal to 2 to 1. and smallest energy change will result in the largest lambda value. So all you have to do is find the energy difference from 2 to 1. Okay. So that then you can use the Rydberg formula. So 1 by lambda equals R times 1 minus 1 by 4, right? 1 minus 1 by 2 square. And for the Balmer series, it will be the same logic, but lines that come to n equal to 2. So the shortest energy transfer is from 3 to 2. Okay, this will be giving out a photon with the largest wavelength. So this is lambda 1. The next one equation is 1 by lambda 2 equals R times 1 by 4, 1 by 2 square, 1 minus 1 by 3 square. This will be the answer for the second case, and I guess it is 2. Yes, 5:27. You will get as the answer. Actually, the answer key is written over here. You guys can later get the PDF and check it. Yeah, it is the second option. Okay. Nuclear physics. Nucleus of mass number A and radius R. Density of the nucleus can be. This is actually independent of A. You can write mass by volume of the nucleus to figure out the density. So instead of mass, you can use so the mass is proportional to the mass number, if you guys remember, right? And the density density equals mass by volume, and volume is going to be proportional to R cube, right? And you guys remember the result, which was the mass number is proportional to R to the power 1 by 3, right, for a nucleus. So if you cube the radius, wait, or was it the opposite way? The radius was proportional to mass number to the power 1 by 3. Was it like this? Don't even remember anymore. I'm too tired. But yeah, it is independent of A, right? You guys remember that? NCRT fact. Yeah. Yeah, this was the formula. It's mass number to the power 1 by 3. Okay. All right. Moving on. So now once you do R cube, it will be cancelling out with A. Energy released when two deuterons fuse to form a helium nucleus. Binding energy per nucleon of H12 is given. Binding energy per nucleon of helium is given. So basically the equation is something like this. This is, I guess, helium. So the binding energy per nucleon. So all you have to do is energy released will be just the energy of products minus the energy of the reactants. Okay. And now all you have to do is multiply the number of nucleons with the per nucleon term. So for there are two H12s, right? So what you will do is first let's do product. So product is helium and we have 4 nucleons here. Per nucleon has energy of 7. So 7 into 4 you will do 28. For reactants there are 2 hydrogens, right? 2 deuterons. So 2 you have to put, and number of nucleons is 2, and the per nucleon term is 1.1. Okay, and this will give you the answer. Okay. So 4.4, I guess this will be the answer, third one. Okay. Maybe bhul gaya tha. Oh yeah, the independent of wave. Yeah. It's also written in NCRT, I guess. Next question, Zener diode, I guess. So take Zener break. So this is a Zener circuit, and Zener breakdown voltage is given as 4 volt. Okay, so the logic here is simple. First, you have to ignore the Zener diode. and you need to try to figure out what is the voltage across this diode, which will be the same as the voltage across this 400 volt ohm. Okay, so we have a 100 ohm and a 400 ohm. What is the voltage across the 400 ohm? That you can just use the result, right? So the total volume times 400 divided by total 100 plus 400. This will give us the voltage across 400 ohm. If you want the voltage across 100 ohm, instead of this 400, you write 100. So this is going to be the answer, 48 divided by 5. This is going to be greater than the Zener breakdown voltage, if you see. So the voltage across, let's say AB, let's call this AB, this VAB is bigger than the Zener's breakdown voltage. So which means there will be Zener breakdown occurring here, and if Zener breakdown occurs, then what that will do is it will make VAB equal to 4 volt. Okay, it will make VAB equal to 4 volt, which means this voltmeter will read 4 volt, or basically this resistance, across this resistance we will have 4 volt. And I guess what is the question? The reading of the ammeter. So that will be 4 divided by 400. Okay, and multiply by 1000 to get milliampere. And I guess the answer is either 3 or 2. Yeah, it will be 3. Option 3. Okay. Are you asking for the my original channel? Ansh. So logic gate problem, output is y equal to 0. So we have to individually check it. A1, B1. So A1 goes through here, B1, both 1. So which means over here the output is 1. B equal to 1 goes through here, not A. So this will be 1 and 0, but this is a OR gate. So effectively this will be 1. 1 and 1 goes through the NAND gate. So this will be 0. Okay, so that is correct. So I guess it's A option itself. Wait, that was an easy question, unless we made a mistake. Output is y equal to 0. Yep. Okay. Choose the correct logic gate for the given truth table. Logic gate, I guess you guys should revise it a bit, because every shift is having one question at least. I mean, one question. Oh yeah, that is just a printing thing, man. Actually, the operator only had a few hours to like print it, so there was some error here. So yeah, this question also you have to individually like put it like A0, B0, and just see what happens. I guess this is the OR gate. This will be the OR gate. This will be the AND gate. You know, and you guys can check out the options. I guess the answer is I don't have the answers. Answer you can check it over here. I'll share the PDF with you. The answer is written over here. Okay. Next. Series LCR connected with this power factor. So a power factor question appeared today as well. Power factor is simple. Oh yeah, the figure is missing. So yeah, basically in this question I remember XC, XL and R was given. Okay. And then they were asking the power factor. And so basically you first draw the impedance triangle, and this part will be the XL minus XC part, the net impedance, right, XL minus XC, and this angle is what we call as a power factor, and this cos theta is going to be R divided by Z. So this question, it had XCXL in the diagram, but it is missing. 6 session 2 पेपर है, मुझे फिजिक्स आती है बट गलती हो जाती है. I mean it happens to everybody, bro. Like where did you do BTech? IIT Madras. So this question is clear. Like actually the diagram is missing. XC, XL and R will be given in that. Okay. Okay, that is it. Then you basically draw this triangle and find cos theta. Cos theta is the power factor. Energy of electron in the Bohr orbit is, this is also the same. Angular momentum is nh by 2 pi, right? So you have to find n. Energy is given. Use the formula z square by n square 13.6, that formula, and you will get the answer. Okay. Electron in an orbit of the Bohr's atom is minus 0.04 E naught. E naught is the ground state energy. Okay, so basically minus 0.04 E naught equals minus 13.6 Z square by N square. But this is just E naught itself, right? So that cancels out, and N square is basically 1 divided by 0.04, which is 100 by 4, so 25. So N equal to 5. And here it will be 5h by 2 pi, right? So angular momentum is 5h divided by 2 pi, and with this you will have to multiply 2 pi divided by h, and you'll get the answer as 5. Okay, this is what they asked. Perfectly inelastic collision, two spheres made of the same material, different masses, moving in opposite directions with speed 10 and 30, strike each other and they stick together. The rise in temperature if all the heat produced during the collision is retained by these spheres is. So in inelastic collision you can find the energy loss, right? This will be just a change in kinetic energy, right? Find out the initial kinetic energy. Formulas are given, speed is given, mass is given. Find out the final kinetic energy. Finally, they basically strike and stick together. They will either move together with same velocity or they'll come to rest. That you can find using momentum conservation, right? m1 v1 plus m2 v2 equals m1 plus m2 into v. Finally, they stick together and move with same velocity. That v you can get, and with that v you can find the final kinetic energy. Change in that kinetic energy gives you the energy lost. Okay, now once you get the energy lost, that energy basically heats up the balls, right? So that energy lost, delta E, once you find, this is equal to ms delta T. From this you can find the temperature increase. Okay, if all the heat produced during the collision is retained by the spheres. Yeah, so here instead of m you will use the total mass, because both the spheres are getting heated, and specific heat of the material is given. You can find the temperature increase. Okay, now there is a shortcut to find this delta K in the case of inelastic collision. Okay, and that formula is actually half reduced mass times V relative squared. Okay, so if you don't know this, you can ignore it, but this is a formula. Mu is m1 m2 divided by m1 plus m2, and V relative, U relative is actually the, as they are coming together with 10 and 30, if you find the relative speed it will be 40. So if you substitute mu after finding it and VREL after finding it, you will get the energy lost in one step. Okay, you'll get the energy lost in one step, or you have to do momentum conservation, energy conservation, find change in kinetic energy, and then get to the answer. Okay, so that is it. That is it for this question. You can get the answer in that bottom right. Okay, once you get the PDF. Two bodies of masses, okay, so body of 14 kg breaks into 3 fragments, ratio 2:2:3. Okay, so you can take it as 2m, 2m, 3m. So 7m is equal to 14. So m is equal to 2. So this will be 4 kg, this will be 4 kg, that will be 6 kg. Actually, you can do the splitting, but basically the two equal pieces fly off perpendicularly to each other with a speed of 18 meters per second each. So this 2 part, let's call it 2m mass. Let's call the other mass as 2m mass. They fly perpendicular to each other with 18 meters per second, right? So let's find the individual masses first. So 2m plus 2m plus 3m. This is 2:2:3, right? This is equal to total mass 14. 4 plus 3, 7m. So from here, m is equal to 2, which means this mass is 4 kg. This mass is also 4 kg. And this mass is 6 kg. Okay. So 4 kg flew off at 1818. So 6 kg would fly off something like this. These are the 4 kg masses with some velocity v. This is simple momentum conservation. Initially it was at rest, so initial momentum of the system is 0. Finally also it should be 0. Take this as the x, this as the y. This guy's momentum is 4 into 18. So 4 into 18 I cap. This guy's momentum will be 4 into 18 j cap. This guy's momentum we don't know. Let's call the velocity vector as v vector. But we know the mass is 6 kg. So plus 6 times v vector. This is the momentum of the third mass. You can get the velocity vector. Okay. Alright. So from there you can get the velocity vector. You cancel out 6, 3, 3. Velocity vector is minus 12i minus 12j. And I guess you can find the magnitude, root of 12 square plus 12 square, 12 root 2. Alright, momentum conservation. Alright, this is a potentiometer wire. So this is similar to the meter bridge idea. R1 by R2 equals R3 by R4, the Wheatstone bridge idea. So if I have 0 current here, similar to the Wheatstone bridge idea, the only difference is that this wire, in this wire, resistance is uniformly distributed. So if you like, what is this wire actually? 50 centimeter length. So what you have to do is, let's call this part's resistance as R1, this part's resistance as R2. So 6 divided by R1 equals 4 divided by R2. Okay. So R1 by R2 is 3 by 2. Now resistance is proportional to the length. So L1 by L2 will be equal to 3 by 2. So now just divide this in 3:2 ratio. So this length will be 3/5 of 50, which will be 30 centimeters. Okay. Second option, yeah. Battery with EMF, and so this is a formula which is important. It's a standard formula. EMF E, internal resistance R, external resistance capital R, and you need to talk about when is power consumption by this capital R resistance maximum. Okay, and that happens when capital R and small r are equal. Okay, so this is a formula that you should be knowing. So yeah, So we'll end with this problem. Okay. The question is, we have to find the reading of the ammeter in the steady state. So we have a capacitor over here. This capacitor is in steady state, meaning that it is fully charged. If it is fully charged, there won't be any current in this branch. We can just ignore the branch, right? You just have to find the current in this ammeter. 8 and 8 in parallel will be 4. This 4 in series with 4, it will make it 8. We have ignored this branch. 8 in parallel with this 8 is 4. That 4 in series with 1 is 5. So equivalent resistance is 5. So current, total current from here is 10 divided by 5, 2 amperes. Okay, so this 2 amperes starts from this branch, reaches this node, splits across this branch and this branch. Okay, so compare the resistances of this path and this path. So what is the total resistance of this path? Answer is 8. So this path also has resistance 8, this path also has resistance 8, so current will be equally split. Okay, so this will be 1 ampere, this will also be 1 ampere. Okay, this 1 ampere continues, it reaches here 1 ampere. Now of course, if this is 1 ampere, then the current through this branch will also be 1 ampere. They will merge together and become a 2 ampere, right? And this will continue. So the current through the ammeter is 1 ampere. Okay, so 1 ampere is the answer. Okay, so that is it for today's lecture, guys. We covered a lot of problems. I don't know how many we covered, like 90, 92 problems. So all the best for everybody whose shifts are coming up. Okay, so that is it. Good night, and yeah, take care.